I think in a minute now, guys. Let's go, let's go. Online, can you hear me? I see the screen.
Yes, sir.
All right, good. All right, let's run through this paper. And remember, tomorrow at 11 a.m., we'll do it again. But it's half day tomorrow, right? So we do one paper, one solution tomorrow. And then Monday evening, we see what we do. Monday afternoon. I think Monday afternoon is gonna be a bring your question session. We don't want to be we don't want to be doing too much Monday. Monday is supposed to be a rest day before the exam. So anybody having a final question, anything like that, bring it Monday. All right? We just have a quick session, about an hour and a half, 2 hours the most. We just do a little thing we call bring your question. Go through them, and then that's it. Body go home and sleep. I go straight into the exam room after that. No more studying. Imagine I made the whole day. Man, just start back, I go start this stuff. So last day, I made the whole day, you know. I could have called me. I called me just as I'm about to start this. They call it bad timing. Bad timing. Bad timing. You have very bad timing, sir. All right. I'm going to go up the calculator for this one. Okay. So it's June 2025. Last year, June. It's 2 papers ago. The very last one was January this year. And so it's a very recent exam paper. I sent it to in the group for you guys to do it. A lot of it should have gone through this one before today. But anyway, if it didn't, no problem. Better late than never. Let's see how quick we can get through it so we can go home and gonna grade yourself in the mistake you made. Gonna go walk over it, meds it. This is the last chance really. Alright? Meds it so that you don't go in the exam and make those same mistakes. That's the whole objective. Eliminating mistakes from now. Alright, so that's another user calculator question. 3 marks question. And I must give each of these answers in exact form. So I want us to work this out. Put that in the calculator. Simple and straightforward. That's 3/2 squared. Then I subtracting 1. And then I added 6. 7.25 is the exact form. That's an exact number. 7.25. You want to give it as a fraction? Did this express as a fraction? No, they didn't say express as a fraction. They the exact form. But it could also be written like this or like that. And if I'm in the exam, I'm give them all of it. Because if once the correct answer is on the paper, they have to give you the marks. So it could be 29/4. So it is this one, and also this one. 7.25. Alright? This one down here now, same thing. Put that in the calculator. Exactly as that appears there. Make sure you always clear the calculator. And you type this in the calculator. Know that this is a division sign, not a plus sign. Sometimes the division sign looks like plus sign. You have to look carefully and make sure. Alright? So it's an open bracket. 2.1 times a fraction. 10/7. Close that bracket. That's a plus. That's a 12. And that's division. And it's a mixed number. So you don't construct this number. You use a mixed number key on a calculator. Right? Some people put in a 1 and then they try to put the 3/5 beside. It's not the same. That if you put this in the calculator like this, this is why you see it as 1 times sugar 5, which is wrong. You have to use the mixed fraction key. So on the calculator, there's a key like this. And above that, the second function is a key like this. But for this number, this is the key I want to use. Get me? That's the key I want to use, the mixed number key, the mixed number function. Some people trying to construct the 1 and 3/5 by putting 1 and then put 3/5 beside it. It's not the same. All right, you're gonna get the wrong answer if you do that. All right, so that's why we have to practice and get the wrong thing and then learn from the mistakes. So you can't go in the exam and just go in the exam like that. You have to practice, make mistakes and so. This is 10.5. It's an exact number, 10.5. Or it's 21/2, since I have some fractions. Or it's 10.5. Like that. You know what those I give? Yeah, good to go. All right? Those are like a 3 marks question. I believe that some people still don't get them. One, because they don't use the calculator properly. Sometimes because they don't enter the values properly in the calculator. And sometimes because they have a full calculator. All right? Let's not do that. We need these marks. Can be the big difference between a grade 1 and a grade 2. Here now, the consumer arithmetic. It says Miranda earns this amount of money per month, 8,316. She spends 470. 470. Mr. Sharp, 370 left. Must be thinking that. If she spends 470, there's another 370 somewhere. So she spends 470 of the money on utility bills, on food, and on personal items. And see the rest here now, she saves the rest. This is the other 3/5 now, 3/7 now. This is the 3/7 that remains. The amount that is left. This is the amount that is left. 3/7, the remainder. That amount is saved. That's 3/7 is saved. The fraction that is saved. It says, what percentage? I want the percentage. What percentage does she save? It is the 3/7, but they don't want it as a fraction. They want it as a percentage. So no problem. Let's multiply by 100. So she saves 3/7 is the fraction that she saves. As a percentage, you multiply by 100. That is it. Simple as that. So it's 3/7 times 100. And remember the question, remember the first paper I said earlier, when the answer is not exact, give it to 3 significant figures. And in the case of degrees, give it to 1 decimal place. This is not degrees. So you're going to give this 42.9% is the answer, 42.9%. Right? You're expected to give your answer correct to 3 significant figures. All right. Next question says the portion of earnings spent on the utility bills, the food, and the thing that's a 4/7 talking about. This is talking about the 4/7 portion. This question is now talking about the 4/7 of the total amount. What is the total amount again? This 8,316. 4/7 of the 8,316. All right. So the portion of that is divided in the ratio 5:3:4. So they take it and they divide it out into 12 parts. 5 parts, 3 parts, 4 parts for a total of 12 parts. So this ratio is a total of 12 parts. So part of it is 5/12. That this part is 3/12. This part is 4/12, and it's respectively. So the 5 corresponds to the utility bills, that's the 5. The 3 corresponds to the food, and the 4 corresponds to the personal items. All right, question says, calculate the amount of money she spent on the personal items. The personal items is the last part. The personal items is the 4 part. All right, so remember now, this is 4/5. Don't the calculator. This is 4/12, sorry, of the amount that is left. Remember, it's 4 to 7 that was left. So it's 4 to 12 off that amount that is left. So it's 4 to 7 of the amount that was left. 4/7 of the 8,316. Over understand. Some people might have worked this out first to see what that value is, and then the 4/12 of that. All right. So that is the calculation we're doing. Let's see what it comes out to be. All right. Anybody else got that? Oh, and a bride. How much? All right. Let me check it myself, statement. Let me see if I'm a bride for true. 4/12. 4/12 times 4/7 times 8,316. Wow, on a bright man. Good. Beautiful. That's it. 2 marks for that. Next part now says Miranda saves some of the money each month. Miranda saves some of the money each month. Remember, they told us that she saved what? She saved this amount, right? 3/7, right? She saved 3/7 of the money. 3/7. So Miranda saves some of the money each month. They say it's 3/7 she spent. Remember that, 3/7. It says, show that her annual savings is this. All right. So she saves 3/7 and it's monthly. So therefore, the annual amount is going to be 12 months times the amount that she saves. And the amount that she saves is 3/7 of, what is it again? 8 too much? 8,316. 8,316. But understand, this is the amount that she saves per month, 3/7 of the total. And that's 12 months because you want the annual amount. Work that out and that will give you the answer. So it's 12 times 3/7 times 8,316. Beautiful. And you get the exact value that they say. See? 42768. 42768. Most like these questions where you know the answer. Right? You know you're right. You know you get that 1 mark. Let's continue. It says, she invests this amount that she saves in her credit union, which pays compound interest of 5%. So remember, the 5% is charged on the amount in the account at the time, over the period, right? Per annum. It says, what is the total interest after 2 years? And then they give us a formula here for compound interest. But we have to realize for this formula is that the A in this formula is the accumulated amount, including the interest. So the accumulated amount there includes the principal amount and the interest after a number of years. That's the compound interest formula. And this question is only asking us for the interest. See? Calculate what is our interest. So the interest is going to be the accumulated amount minus the principal. That's what the interest is going to be. So you have to be careful, right? The A in this formula is the accumulated amount, P is the principal amount, the R is the rate percent, and the N is the number of years. All right. So the interest that they want is going to be equal to the accumulated amount minus the principal amount. And the accumulated amount is this formula right here. So it becomes the P into 1 plus R divided by 100 times N, and then subtract back the principal amount. So what is the P, what is the R, what is the N? They are up here. They're smart then. So this figure here is your N, 2 years. This figure here is your R, and the R is 5. The percentage in the 5 is taking care of the 100 and a year. That's what the 100 and a year stand for the percentage, right? So the R is a 5. Boy, stop talking. And the principal amount is this that you invested. That is the P. This amount is the P. All right, so putting in those figures in this formula, we're good. Whatever that gives us, I have to put those figures in, we're good. So it's going to be $42768 into 1 plus, it is 5 over 100 raised to the power 2 for 2 years, and then subtract the principal again, which is 42768. And that will give you the the answer. Some person might have calculated the accumulated amount first and then subtract the principal afterwards. But, you know, something you cannot do your calculation one go, like this. All right, so let me do it now. So it's going to be 42768 times bracket. That's 1 plus 5 over 100. You can put it in the calculator the same way. Those brackets, square that, and then subtract the same figure again. 42768. And I'm getting 43. I'm getting $sign 4383.72. Anybody got that? Beautiful. You're not bright. I could not get some grade 1 at the exam, man. That is it. All right, let's go. Next question. Wants us to just factorize these things completely. So the word completely means that no part of it must be left that can still be factorized further. So here now is just two terms. And we're looking for a common factor first. Here are a common factor. A common factor in each of them is xy. So you factor the xy. You factor the xy out of this. Only the y, one out of the y come out. So you have a y left back in there. The x is already out here. Minus, you factor xy out of this. Out of the square, you're going to be left with an x. If you're not sure, you can just expand it back. This time, this again going to give you back that. And this time, that is going to give you back that. So if you're not sure, just expand it back in your mind as in a bit. And then you check inside here if you can factorize it further. No. You can't factorize it anymore, so you're done. That's it. All right? Easy as that. Next one. That's a quadratic. You can factorize it on the go, but let's go through the process again. All right? We're not going to say, all right. Okay. After time, you'll be able to factorize it on the go. I just observe, especially when the n value is a prime number. We the only factors of that number is 3 and 1. All right? The only factors of this is 3 and 1. 3x and x. And so sometimes we cannot easily factorize when the n value prime like that. At least one of them prime. But anyway, let's go. Let's go to the process.
Sure.
Yes?
Sir, could you go to the answer above?
This one?
The first contract we sign is for.
Oh,
Got
okay,
it?
okay. Yes, sir, got it.
All right. So here now, let's go to the process. So it is 3 times negative 10. If I multiply the two n coefficients, and that's equal to negative 30. And you want factors of the negative 30 that add to the middle coefficient, which is just a positive 1. There's no number for the x. So it's just a 1. So you want a plus 1. Factors of negative 30 that add to plus 1. You must know 6 and 5. But let's say in the exam you're doing Friday, you can't go to 6 and 5. You can test the factors until you find it. Looking for factors of negative 30. Factors of a negative number is such that 1 must be positive and 1 must be negative. You have to give the larger of those two factors the same sign of this that you want the sum to be. All right? So the first two factors is 6 and 5, I know. But let's say you don't, you never pick up, say 6 and 5. You can go down the list of factors and don't forget 1 and the number. So the first factors will be 1 and 30. Is the larger one the positive, smaller one the negative. But 30 minus 1 is 29. So you don't want that. You're looking for 1. Next factor of 30 is 2 and what? 2 and 50. If the larger one the positive, smaller one the negative. But 50 minus 2 is 13. You don't want 13. It's 1 you want. So you go again. The next two factors of 30, 3 and what? 3 and 10. 3 and 10. The larger one positive, smaller one negative. 10 minus 3 is 7. You don't want 7. It's 1 you want. Next factor of 30, 4 and what? 4 and 1, nothing. You look for whole number factors. 5 and 1, 5 and 6. 5 and 6. The larger one positive, the smaller one negative. 6 minus 5 is 1. So yes, you're going to split this x into minus 5x plus 6x. I can turn them the other way around and put 6x minus 5x. Same difference in the end. All right? So we're going to split it now. So ready now. Back over here. So the 3x squared comes back as it is. And this x, I'm going to write it now as 6x plus 6x minus 5x. And then put back the minus 10 out here. I must always check if what you split the middle term into would give you back that. Always do that little check just to make sure. In case they put the wrong sign or something. And in this case, it would 6x minus 5x is that 1x there, x. And they're gonna do factorization by a part. So factorize those two by a part. Highest common factor you want, not just a common factor. The highest common factor in those two values there underlined is 3x. So factor out the 3x. 3x factored out of this leaves us with an x. 3x out of this leaves us with a plus 2. And you must have the same thing in the bracket where you factorize these two. So I'm just gonna put x plus 2 over here first. And then work out what I must factor out there. It must always be plus a value or minus a value, one of the two. All right? So you can know what it is. You can divide the negative 10 by the 2 in here. That will be negative 5. Or you can divide the negative 5x by the x in here. That still will be negative 5. So negative 5 you factor out. If you're not sure, you can do the negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. So if you're not sure, you can do like an expansion again. So what it is now is that your x plus 2 is a common factor and they are connected with the 3x and the negative 5. So those now form the factors. The 3x minus 5 are connecting your x plus 2. And that is your answer factorized. Very good? Beautiful. And if you add them the other way around, that's okay. If you add x plus 2, 3x minus 5, still correct. Right? The order doesn't matter. Next one. Let's say must solve for n. In other words, find n. This looks like an indices question. Multiple ways to do it. You're trying to find n. Multiple ways to do it. Right? So we can use a straight indices method. You can solve it down all kind of way. I don't even know which way to approach it. And let's say I'm gonna do it where I leave 4 to the n on one side and see what it equals to 4 to some number. Some other number over here. So whatever that number is, equal n. Let's use that method. All right. So what I'm gonna do then, to get rid of this 4 cube, I'm gonna multiply. Because this 4 cube right now is dividing, you know, it's same as 4 to the n over 4 cube equals 1 over 4. So if I take this 4 cube and multiply it up here, so I'm gonna be left with 4 to the n equals 1 over 4 times 4 cube. And this 1 over 4 times 4 cube is that this 1 over 4 will cancel 1 out of the 4 cube and leave with a square. But understand that? But understand that?
Can I repeat that, sir?
I'm saying this is 4 cube divided by 4. This is 1 over 4 times 4 cube. So I'm gonna get the 4 cube here, so I take this and I multiply it up here. Cross multiply. And so it becomes that. Then this is now like 4 cube divided by 4. So this can cancel away 1 of the 4 out of the cube. Right? So you cancel away 1 of the 4 out of the cube. So 4 into this, 1 time, 4 into this, cancel 1, leave you with that 2. I can look at it this way. This 4 cube, we can say that another way, 1 over 4. The 4 cube right here is the same as 4 times 4 times 4. So this will cancel 1 of them. And then this 4 times 4 is 4 squared. 4 squared. So anyway, you look at it, the end result is the same. But let's do the math like big people. So it's 4 cubed. So this 4 under here cancels with 1 of them, leave it as 4 squared. So this side becomes, we'll get 4 to the n equals 4 squared. So if 4 to the n equals 4 squared, then the n equals 2. And the n must equal 2. All right? And the multiple rate can be done another way right here. So we're gonna straight indices method. Watch this now. So we have 4 to the n divided by 4 cubed equals 1 over 4. Let's use that indices method. So we know that when you divide indices, you subtract the power. So this side can become 4 to the n minus 3. 4 to the n minus 3. Subtract the powers. And this 1 over 4 is really 4 to the negative 1. 4 to the negative 1. All right? 4 to the negative 1. So it means that this equals this. So we can say, therefore, n minus 3 equals -1. And we carry over the 3 over there, so the n becomes -1 plus 3, or 3 minus 1, the n equals 2. And I can do it 10 different ways, but that's enough. All right? Many multiple ways it can be done. Multiple ways it can be done. Multiple ways. Let's continue. This question says, the length of 3 sides of a trapezium are shown in the diagram below. The area is 750 square units. It says, write down an expression in terms of P and Q for the area of the trapezium. Remember, the area of a trapezium is half the sum of the parallel sides multiplied by the distance between the parallel sides. Right? Area of a trapezium is half the sum of the parallel sides. This is the symbol for parallel. I'm just write it down. Half the sum of the parallel sides multiplied by the distance between them. Perpendicular distance you want as well. Not just the distance between them. You want the perpendicular distance. Shift this over someone. Between them. All right, so using that formula, that expression becomes half the sum of the parallel sides. The parallel side here, so 4p plus 3q. 4p plus 3q times the distance between them, which is 6p. That's 6p, the distance between them. The perpendicular distance between them is 6p. All right, and this can be simplified. This can be simplified. Let's simplify it. Let's put this up a little bit and simplify it. So we can say half of the 6p is 3p. 3p times 4p is 12p squared. And 3p times 3q is 9p cubed. But understand that? But I go with that. So we can leave this as the answer. And you're expected to simplify your answer. So this is an expression for the area.
Wait, sir, I don't understand. You could repeat that part?
Repeat which part?
The one part at the end where you
The
simplify
last
it.
part?
Yeah.
All right. So half of 6p is 3p. So that may have now 3p times the bracket here, so 3p times 4p give me 12p squared. And then 3p times 3q, 3 times 3 is 9. And the p times q is pq. Good with that? Okay with that?
Yes, sir.
All right. So if you want to do more steps, just as CSEC, you don't give a lot of space to work. And it's only 1 mark for the question. So you don't want to be writing 10 lines to get something. So you have to learn to work efficiently. All right? I don't have a lot of space to write a lot of lines to do these questions. Next part now says, given that Q equals 2P, determine the value of P. So remember that this area is actually equal to 750. That's what they told us. So cannot forget that information. And then they're giving us some additional information to say the Q is actually 2P. So let's set it up. The area, which is 12P squared plus 9PQ, they're telling us that is 750. That's what we know. 750. And then the Q is 2P. So we're going to substitute 2P right here so for the Q, right? So we're going to put the Q right here, so, and put 2P for the Q right there. That's what they said. The Q is 2P. So when you do that now, it's going to become 12P squared plus 9P, and the Q becomes 2P. That's still equal to 750. Then this right here so now becomes 18P squared. And this is 12P squared. But the 92 is 18, you know, so that's 18 p squared. We're looking at right here, so now we know. That's 18 p squared and 12 p squared. 18 and 12 is 30. So that's 30 p squared equals 750. You're going to have to divide by the 30 now, and then square root to find the p. So the p squared is going to be equal to 750 divided by 30. And then now, what the p is now, going to square root both sides. So the p is going to be the square root of this. I don't have to waste time and work it out first. I can have to one final calculation. I don't have to work it out step by step. I don't have to work out this value first. I don't need to work it out first. I just know that the p is going to be now the square root of 750 over 30. And so I do one calculation at the end and get my answer. Why don't I put plus or minus? Normally we calculate square root if I put plus or minus, but I'm leaving it off this time because the p refers to a length, a distance. The p is a measure of a distance. And distance can negative, length can negative. So there's no need for the negative with this example, right? So let's work out with the calculator. So it becomes the square root of a fraction 750 over 30. And that looks like 5. Good. And so p equals 5. P is the value of 5. But after that, all right, we never get to go and do it over again. More mass equals better math. All right, a lot of people might have forgotten that this thing was equal to 750, everything important. So you see, they put it up here at the beginning of the question. They ask you one question here, so that has nothing to do with the 750. And then I ask something else down here that needed the 750. So you have to remember the 750. All right, every piece of information that they give you, sometimes you do, you put it on this. Like me, you know, remember I write it on this 750 square units, 750 square units area. Just put it on the diagram, 750. So I don't forget. All right. So sometimes that's what you have to do. Sometimes information get hidden in the wording, put it on the diagram. All right, that is it though. Number 3. It says using a ruler, pencil, and pair of compasses, construct triangle PQR, where PQ is 9, the angle at P is 60. Same thing. Angle at P is 60 degrees, and PR is 12. Sketch it before you construct it. I'm going to sketch it first. So you have a line PQ. I like to put it along the side, and the base PR mean PR. I'm going to make that with 12 centimeters. Then I need a 60 degree up here, so 60 degree up here, so. And PQ is up here, and then PQ is 9. This is 9 centimeters. So that is what I'm going to sketch, what I'm going to draw. So you sketch it first, and then you construct it. So we need to construct this now. So we're constructing a 60 degree angle, which is the easiest angle to construct. So let's get the construction thing right here and do it. All right. So remember, the first line we needed was a 12 centimeter line. So use the ruler. I'm gonna draw that 12 centimeter line first. From 0 out to 12. All right. I'm gonna clear that away with the ruler. We're gonna construct the 60 degree over this end. I construct the 60 degree down at this end down here. Let's use the reading for the construction lines. So come to the end of it. Put me a compass, a reasonable length. Lock it, tighten it, and you make an arc, which is about 60 meters. I'll get longer than 60 angle, 60 degrees. I mean, move the point to here. We cross with the arc, intersect the line, rotate around, and you cross that. That is 60. All right. Then now I know that I need 9 centimeters. I need a line that is 9 centimeters now. So you can do that multiple ways. You can make an arc that is 9 centimeters like this. Bring back the ruler. Let's put over here and measure 9 centimeters on it. So 0 over to here. And you open it up to 9. That's about 9. Yeah, that's look like 9. Lock it. Let me change the color for that one. Alright. And then put it here. I need 9 centimeters from this point. So I'll come up here. I'm gonna make an arc up here. So I know that my point up here is on this arc. Alright. Then I'm gonna draw the line now through the intersection from a 60-degree line. So I'm gonna come through here now. I think I miss it, you know. Come through this intersection. Come through this intersection here. Extend it out. Make sure you pass through the cross and the intersection for the 60-degree. And where this line meets the blue now, that's where the point is. That's my 9 centimeters. And release that. That is it. All right. And then I need to just complete the triangle. So it was what? It was R. It was P, R, and Q at the top, right? P, R, and Q. So down here is P. Down here is R. This intersection is Q. And then I can just complete the shape. Just draw a straight line from the intersection up here. Put the wrong thing. All right. Straight line, Mr. Shaw.
Wait, sir, is why a mark at the top? What did you make a mark at the top, sir?
I put a mark for that blue mark is 9 centimeters from P.
Oh, okay.
So I know that my 60-degree line must intersect here. That's where the Q is. So I can label up this thing now. So this was 12 centimeters. This angle is 60 degrees. Side here is 60 degrees. This is 9 centimeters up here. So, and that's my construction. Nice and easy. Let's copy it over. That is it. All right, very good. That's a construction. All right. Question done. 3 marks for that. Let's go. Next question, transformation. It says, the diagram below shows 2 quadrilaterals R and S, where S is the image of R. S is the image of R. So S is the image of R. So the transformation is from this one to this one, right? S is the image. So we're going from this one to this one. So there's a change in size. So you know you have an enlargement. We can start have some information from before we even start. So for example, the scale factor is 2. Because this line, for example, was 1 unit and it has grown to 2 units at a multiplier of 2. Also, the scale factor is positive because the image and the object pointing in the same direction. So like for example, this end, this little vertex pointing up, and this one pointing up as well. They're pointing in the same direction. It is not inverted. So the scale factor is 2. The next thing we need to find is the center of that enlargement. And to find the center of the enlargement, we can join the corresponding points like this point and this point, join them with a straight line and extend it. And then like this point and this point, join them and extend it. And where they meet is the center of the enlargement. We have to read properly, right? I'm just kind of sketching it out quickly. So let's see now. I'm gonna join these 2 points, this one and this one, with a straight line, and see where we end up. So passing through here, passing through here. So the line is gonna go like this. All right, passing through those points. And then now the next one pass through here, pass through here. Let's see where that one goes. Pass through here, pass through here. So that one looks like it will come to these 2 points. All right, and so they meet right here. Notice they meet right here. So I'm saying that is the center of my enlargement. And I can double check it. But in addition to the size being doubled, scale factor also doubles distance. So for example, this distance to this point was doubled down to this point by a scale factor of 2. You can see that's a doubling of that distance. Scale factor also doubles, affects distance from the center. This distance, for example, to this point was doubled down to here. So the scale factor also affects distance from the center. So you kind of double checking and making sure that yes, this is the center of your enlargement. All right, so we can label that point as coordinates 3, 7. So mark it 3, 7. This point is 3, 7. Put it in red. All right, you know that is correct. Based on that construction, we can go and write the description now. We have found the 2 components of enlargement, center and the scale factor. I want to know the positive scale factor. So the transformation is an enlargement of scale factor. Let's write that better. An enlargement of scale factor two and center is a 0.37. That's what we said, right? 37, let's just make sure. Yes, 37. 37. That is it. That point here is 37. That's the center of the enlargement. All right. Let's continue down here now. It says on the grid, draw the image of quadrilateral R when it is translated -4, 5. Now remember, -4, 5 means 4 to the left, means 4 to the left. Four to the left and 5 up. That's the up, not the vertical. 4 to the left, 5 up. That's a -4, and that's a 5. That's how it moves a point. This moves a point from here to there, like that. It goes 4 to the left, 5 up. So we're doing the translation on the image and the object R, 4 to the left, 5 up. And so, because the shape is going to be the exact same thing, that's this one. We can just move 1 point and then draw by the same shape around that 1 point. 4 to the left, 5 up. So let's say we're using this point here. So 4 to the left, 5 up. So we're gonna go and you always check the grid, make sure the grid, 1 box is 1 unit, horizontally, yes, and 1 box is 1 unit vertically. So you're not moving by grid, you're moving by units. All right, so that's 4 to the left, 1, 2, 3, 4, 5 up now. 1, 2, 3, 4, 5. So this point is coming right here. I'm sure you can use a different point, you know. It's a different point. I don't want it in the way. I don't want it in the way. Let me use a different point. Let me use this point down here. So let me use this point. 4 to the left, 5 up. 1, 2, 3, 4 to the left, 5 up. 1, 2, 3, 4, 5. So this point is coming to here. And then all you have to do is draw by the same shape around that point. All right? 4 to the left, 5 up. Draw by the same shape. So let me use a different color for it, purple. So I'm going to draw about this horizontal piece first, which is 3 units. 1, 2, 3. Then this vertical piece is 1 unit. 1 unit. Then this vertical piece up here says 3 units. 3 units up. 1, 2, 3. And then close the shape with this diagonal piece. This diagonal piece closes the shape. And that is your image of the translation. And then I must label it what? I'll tell you what to label. Label T. So I'm going to label this with a T. But I go to that? But okay? All right. The next transformation is what? I want us next to do this. Let me put this to the side for this one. But this one is up here. Really. Put this up here. So. All right. We're doing this one. This one now. And that one they say is draw the image of R again. A rotation 180 degrees about the origin and label it N. Now, what we must know about a 180 degrees about a point is that it is the same as reflecting to the point. It's easier to reflect to the point rather than try to do the 180 degrees rotation. So a 180 degrees, a 180 degree gone over here. All right, right. So 180 degrees rotation about a point, set up like this. This thing, 180 degrees rotation about a point, about the origin, you can say same as reflecting through the origin. That's one way we can do it. And so it's like object distance to the origin equals image distance from the origin on the other side. Right? So like you have, like, let me use a different color now. What color can I use? Let me use green. Let's use green. So like I have this point. So it's 1 unit to the origin. It's going to go 1 unit on the other side of the origin. So that point is coming to here. Then this point, come to the origin near, so it's going to go the same distance on the other side of the origin over there, so. But there might yet be another easier way to do it still. All right, so that's one way I'm showing. But let me show you yet an easier way to do it. An easier way to do it is to know the matrix for reflecting to the origin and know what the transformation looks like. So the matrix for reflecting to the origin are for the 180 degree rotation matrix. 180 degrees rotation about O, about origin, is -1, 0, 0, -1. How that works? It reverses the coordinates and negate them. No, it does negate the two coordinates. Because if you multiply that by a point, xy, just as an example, use that matrix to multiply by a point xy. Then the -1 times the x is going to take it to negative x. And 0 times x is 0. And the -1 times the y is going to take it to negative y. So it means that when you reflect through the origin, or do a 180 degree rotation, a point xy is going to go to -x -y. So all we have to do therefore is negate the coordinates to see where the image points are. Just negate the coordinates, right? Which might be the easier way to do it. So for example then, I can maybe use the blue. So for example then, this point which is 1, 1, is going to go to -1, -1 right here. This point which is 4, 1, this point which is 4, 1, is going to go to -4, -1. -4, -1 to here. This point is coming straight across to there, so. Which is here, so. And at this point is what? This point is 4, 4. We're going to go to -4, -4, -4, -4. So it's coming down to here. And then this point, we don't do this point yet. This point is 1, 2. This point is 1, 2. It's going to go to -1, -2. -1, -2 to here. Coming to here. And so you join those points, you have your shape. Join those two. Join those two. Join those two. Join those two. That is your shape. All right? So instead of trying to rotate, more things you know the better. If you know the matrix that does it, you apply the matrix to a general point. XY is what we call a general point. So you apply the matrix for the transformation to a general point, see where it takes you, and just apply that transformation to all the points. This tells you that it negates the values without switching them around. That's all it does. Right? Negate the values, the coordinates. And that's what we did up here. And they must label it M. So this is now M. And that is it. Very good at that. Very good. So this was our -4, +5 that we did for the translation. Anyway, that is it, guys. Next question. That question done. Now we come to this question 4, which is a line and a graph. Like this question because everything is there. You can count out the gradient, you can see the y-axis, intercept, all those things, right? It's in front of you. So I said, the graph below is a straight line of PQ, shows the straight line PQ. What do they want us to do? They want us to find the gradient. We have to calculate, you can count it off. So we can choose any 2 points and count out the gradient, rise over run. So for example, we can use this point and this point. We're not counting grids, we're counting the units. So this vertically is 1 unit, between 3 and 4 is 1 unit. Horizontally, 0 to 1 is 1 unit. So the grid is 1 unit. So always make sure. So look from this point to this point, we'd have to rise 2 units. See it here? Rise 2. And then run 1 across here. So run 1. So that's the gradient. Rise over run. 2 over 1. Easy as that. So the gradient of this line is rise over run between any 2 points. The rise is 2 and the run is 1. 2 over 1 is 2. So gradient of that line is 2. Argument done. Simple as that. No need to calculate. No. Graph is there. Count it off. Next one. Write down the equation of the line PQ in form y equals mx plus c. All right. So we have the m already. The m is equal to 2. Now we need to find the c. The graph is there. Go up on the graph and look for the c. The c is where it crosses the y-axis. See it right there, so? This is the c. Cross y-axis at 1. So the c is equal to 1. So no problem. The c is equal to 1. C is equal to 1. Put them in there. Easy. Therefore, y is equal to 2x plus 1. Easy. Get your mark and go about the business. All right, no calculation needed. The graph is there. Question done. Then we get this functions question. F and G. That is F, that is G. 2 functions. All right, they want us to find G of -6. Put the -6 in the G function. Quick and fast. So this then becomes equal to 3 times -6 plus back the 2. Some people made a mistake of putting it in the first one. But the first one is F. Put it in the one that they said, G. Looking for G. So put it in the G one. Now this is -18 plus 2. -18 plus 2 is -16. Am I right? That's the answer. -16. Next question. I want G to the -1. I want G to the -1. I'm going to start by saying G equals, what is G again? G is 3x plus 2. Easy. 3x plus 2. I'm going to inverse it. Some teacher would have called it Y. I call it the same letter as the function. No problem. And then when you take the inverse, the G becomes X. And the X becomes G to the -1 plus 2. And we're trying to make this a subject now. Or make that a subject. Carry over the 2 first and subtract it. And then divide under the 3. Simple. 2 steps. So you get X minus 2. You carry over the 2. Divide the 3 under there now. Divide it by 3. That leaves you with G to the -1. That's it. G to the -1 of X is this. So you can write the solution now. You can say, i.e., that is G to the -1 is X minus 2 over 3. And we can just put in back the of X now at the end. Put in back the of X. So G to the -1 of X is equal to that. That is the answer. 2 marks for that. Quick and fast. Nice and easy. Done. Next part. They want us to show that f of G is equal to this. So remember, f of G means G into f. So all we do is calculate it and show say it work out to this. And let's remind ourselves now, what is the f and what is the G, so we can do it. The f was what again? x squared, what is it again? X squared minus 1 and 3x plus 2. X squared minus 1, and the g is 3x plus 2. And this composite function means that we're taking the g function, putting all the g, taking the entire thing that is g. I'm going to bring it and put it in the f function where the x is right here. That's how you form the composite function, f of g, which means g into f. So we can do it now. So the f of g of x then becomes equal to, we're going to put the g right here where the x is, all of it, which is 3x plus 2, put the square on it, and then subtract 1. Subtract this one beside it. And now we have to do is expand this and simplify it down until we get that. That's what it is. All right, so I'm going to have to expand that. Now remember, when you expand a perfect square, guys, you get 3 terms. Get the first term squared, which is 9x squared. Then you get twice the product of the 2. Twice the product of the 2 is the middle term, means you multiply these two values, the 3x and the 2, you get 6x, and then you double that to 12x. Then the second term squared over here, so it's 4. So you get a plus 4. Plenty of people going to leave out this middle term and get it wrong. When you expand a perfect square, you get 3 terms. First term squared, twice the product of the 2, second term squared. So this now is just expansion of that. We're subtracting the one beside it. So let's go now and put minus 1. Then what happens now? This becomes 9x squared plus 12x plus 3. So initially, 3 is a common factor of these values. So you factor the 3 first. So you get 3 into 3x squared plus 4x plus 1. And then this now factorizes into these two factors. I don't forgot to know process of factorize, just put it. Okay, you can see that if you expand this, you're gonna get this. You already show that you know how to factorize this question up here, so with the process. Where was it? The first question. You already proved to CSEC that you already know how to go through the process of factorizing. Where is it? Teacher, you do it already. You don't have to prove it over again. You get me? CSEC already know that you know how to do the process of factorizing. So write this and now just write the factors. You don't have to go no A, B, no A, C, no, and go through the process again. CSEC not trying to test your ability more than once in an exam. All right? So that is it. You already show that you know how to factorize. Let's write this a little smaller. You want to put that space. Let's write the final value down here. So it's 3, and you put in the 2 factor brackets. And this is 3x plus 1 in one of them, and x plus 1 in the other one. That is it. And you have shown it. Shown. Quick and fast. Nice and easy. Next part. It says, hence solve the f of g equals 0. So therefore, put in this equals 0. F of g equals 0. So when I write 3 into 3x plus 1 into x plus 1 equals 0. That is the f of g equals 0. Now this 3 here equals 0, so you can divide it out and it's gone. And you're going to be left with 3x plus 1 alone times x plus 1 equals 0 if you divide out the 3, because the 3 can be 0. Then it's either this bracket equals 0 or this bracket equals 0. If you think of it now, if this 3x plus 1 equals 0, then you would have take the negative, you would have take the 1 and carry it over to become negative 1, and then you would have divide under the 3. So one answer is that x is equal to minus 1 over 3. But I can see that. Or if this bracket equals 0, because the product equals 0, you know, it's either this equals 0 or this equals 0. So if this one equals 0, you know, you just take the 1 and carry it over to become a negative 1. So in that case, x would be equal to negative 1. And so those are the 2 parts of this. Nice and easy. But good? Beautiful. Let's continue. Number 5 says 30 students took a math exam and the marks they scored are shown in the table below. All right, so these are the marks they scored, and that's the frequency, that's the number of students. This is supposed to add up to much? 30 students, 30. So it's supposed to add up to 30. And see, there's 30 for 2, the cumulative frequency column. Remember, the cumulative frequency column is your counting column. So we have counting the number of students you have as you go down the line from score to score, right? So we have counting how many students you have as you go from score to score. And naturally, they're going to want us to complete these two. Naturally. You know that's how these questions are always go. We're going to want you to complete it. So see here, complete the cumulative frequency column, right? So here now we have to add 7 to this. You have 7 more students. 7 and 8 is how much? 15. And then now you have to add 6 to this to get this value, right? I added 6 more students to the 19 you have so far. You're counting as you go. So that's how much? 25. And the double check it now, the 25 and this 5 give you the 30. So you know, so you're good. All right, so that's a completed table right there, the 15 and the 25. It says use information in the table to determine the range. The range is the largest value minus the smallest value when the data is raw, like that, or ungrouped, not raw, when the data is ungrouped. Largest minus smallest. The data was grouped to be largest upper boundary minus smallest lower boundary. Remember that? So the data is grouped, right? And it's measurement data, but this time it's just ungrouped data. So it becomes 10 minus 1, which is 9. 9 marks is the range of the marks. 9 marks is the range of the marks. All right, next one, the modal mark. The modal mark is the mark that occurred most frequently, the one matches the highest frequency. So the highest frequency here, so matching a mark of 3. So 3 is the mark that occurred most frequently. So the modal mark is 3 marks. 3 marks is the modal mark. 3 marks. See, I'm putting the word marks there because marks is the unit of the data. Marks is the unit of the data. Everything important, guys. So centimeters, something in centimeter, I'm going to put centimeters on these. Whatever the unit of the data is, put it in the answer, guys. Everything important. Next one, the median mark. The median mark is the mark in the middle. There are 30 students. They like you divided 15 and 15. 15 and 15. So you have this one ends at the 15. This first group ends at the 15th one. This one starts at the 16th one. So the two in the middle are the 15th and the 16th. You want the average of the 15th and the 16th value. So you're going to have to find what the 15th and the 16th value is by counting. Well, you have the cumulative frequency, which is counting. You want the 15th and the 16th value. Another way you can do it is the formula method for the position of the Q2. So you want the median, teacher. Remember, the position of the median Q2 is half of the n plus 1 term. Half of the n plus 1 term. Which becomes half of 31. I remember the n is 30, you know. Half of 31 is 16.5. That's a 15.5, my mistake. 15.5. So you want the 15.5 term. So it means that you want the term between the 15th and the 16th term. That's what 15.5 mean. I mean the 15th plus the 16th divided by 2, which is what you'd have to do if you line them out individually as well. So Q2 is going to be the 15th value plus the 16th value divided by 2. All right. So now it's a matter of finding the 15th and the 16th value. So see, you know, Q2 equals. What's the 15th and the 16th value? You can know from the counting column. Or the counting column is counting the values for you. That's what cumulative frequency value is. So the 15th value, you reach a 15th value right here. And so the 15th value is a 3. 15th mark is a 3. Right? Okay, so you have 3 marks first, and then 4 makes 7 so far, and then you have 8 more. Right? So the 15th mark is a 3. So you have 3 ones, then you have 4 twos, so you got 7 values, and then you have 8 threes. So the 15th value is a 3. So this is the 15th value. And so the first value over here now in this set is the 16th value. And so this is the 16th value. So the 16th value is a 5. So you're doing the average of these two values. So Q2 then is the average of 3 marks and 5 marks, which is equal to 4 marks. So the median Q2, median is the same as the second quartile. Median and the second quartile is the same. That's what we call it Q2. Q2 is 4 marks. But I go to that. So the paper that we did earlier, the same kind of question. But I should get this right. Or if you never get it right the first time. All right? Let's continue. Then I want the mean mark. So the mean is the sum of all the marks divided by the 30 students. The sum of all the marks that all 30 students got divided by the 30 students. Now you can put in a sum column. But they didn't give us a sum. Let's put over here. So we can put in a sum column, a column that we can sum the values. And sum column is the frequency times the score. So multiply the frequency times the scores. Remember the X are your, the marks are your scores. So this is your frequency and these are your scores. So you said 3 persons get 1. So the total marks of the 3 persons here is 3 times 1 is 3. Then 4 persons got 2 marks. So the total marks of those persons is 4 times 2 is 8. Then 8 persons got 3 marks. Total marks here is 8 times 3 is 24. Then 3 persons got 5 marks. Total marks of those 3 persons is 15. Then 1 person got 7 marks. So the total of that 7 is just the 7 marks. 6 persons got 8 marks. 6, 8 is how much? 48. And then 5 persons got 10 marks. 5, 10 is 50. So we add up all of these. That's the sum of all the marks that everybody got. That's what we call that the sum of FX. That's the sum of the sum. Add up everything there, so. And that tell you the sum of all the marks that everybody got, all 30 people. So it is 3 plus 8 plus 24 plus 15 plus 7 plus 48 plus 50. 155 is the total marks that all the students got. And there were 30 students. So the mean mark is 155 divided by 30. So the mean here is equal to the sum of the sum column divided by the number of students, which works out to be 155 over 30. We that out to the calculator. 155 over 30. That's 5.166. 5.166. That's 5.17 marks. I see this is usually 5.1666 now. So if you correct it, 3 significant figures is 5.17. 5.17 marks is the mean mark. So correcting 3 significant figures. So this figure corrects that and turn it into a 7. All right. But good? But all right. Put 5.2 and so let me give it a marks. But you must practice 3 significant figures, right?
So is what you divided them by?
Huh?
Sorry, I can't really see the screen so well. Is what you divided them by?
If what?
What did you divide the sum by?
I'm not hearing you. What did they say?
What did you divide the sum by?
By the number of the number of students. Because it's 30 students and 155 is the total marks that all 30 students got. So the mean mark is 155 divided by 30. Because there were 30 students, the sum of the frequency. The number of students is the sum of the frequency. All right? These are the total marks that all 30 students got combined. So the average mark, the mean mark, is 155 divided by 30. Go to that. Okay? So this is N. N means the number of students. Or you can put sum of F. N is the same as the sum of the frequency. N is the same as the sum of the frequency. So some people put sum of F right here. Same as N, number of students. All right, let's continue. So down here now it says, the following two-way table shows the gender distribution of students' performance in a maths test, on the maths test. All right? It says A student is shown at random. So once you see a student, it means that you're coming out of the 30. Or there were 30 students. All right? You're coming out of all of them. I say a student is shown at random, and there were 30 students. Find the probability that the student is female who failed the test. You're looking for those who failed and female. That's 8 out of the 30. That's pass. Oh, thank you very much. Very good. Hey, you're bright, you know. So failed and female 13. All right. Very good. So it's 13 out of the 30 is the answer. Thanks for that. Failed and is a female. Yes, I might pass a while ago. But good at that. 13 of them. You're coming out. The important thing is that you're coming out at 30. All right? Because they said a student was selected. Down here now, it says a male student is selected now. So many male students are there? You know, coming out of 9. There are 9 male students. You're coming out of 9 male students now. So like you reduce the sample size to just the male students. Like you put the male student one side, and say, okay, I'm going to pick up probability out of the 9 male students now. And I said, what's the probability that he passed the test? 4 out of them passed the test. So it's 4 out of the 9 students passed the test. 4 out of the 9 boys passed the test. That's it. But other than that, the answer for this one is 13 out of 30, because you're out of the 30 students. This one now is 4 out of the 9 boys passed the test. All right, that is it. Question done. Next question, number 6. Number 6 says, PMQROS is a cross-section of a play area in a park. PQRS is rectangle. PQRS is a rectangle right here, so. Right? And PMQ is a semicircle. So this up here says that half of a circle. A semicircle is half of a circle, guys. Half of a circle. It says O is the midpoint of RS. This is the midpoint across here. So divide the base here, so half and half. Divide here, so half and half. And it says OP equals OQ is 15. So this and this is 15. All right? So that looks like a radius of this thing right here. So if it was a sector, well, not really the radius, no. But this is 15 and this is 15. Forget about that. All right, that is 15 and that is 15. They're equal length. And so this is an isosceles triangle. That becomes an isosceles triangle, right? And in that case, these two angles are the same. This angle and this angle equal. And they have given us this angle down here at 40, the diagram. So it's easy to find those two angles up here. Let's see what they say. So use pi equals 22/7. The first part wants us to find angle OPQ. OPQ. That's this angle I want right here. They want us to find this angle up here, so now, right here. But remember, equal to this one as well. So I use total angle in that triangle to get it. Right? And the equal. So everybody know the calculation in the isosceles triangle already. So that angle becomes equal to 180 degrees minus the 40 degrees. That's the sum of these two, 180 minus 40. But the two are equal, so divide that by 2. So 180 minus 40 is 140. 140 divided by 2 is 70. So each of them is 70 degrees. So these two angles are 70 degrees. Let's put it on the diagram. So this is 70 degrees right here, so. And this is 70 degrees right here, so. As you work out something, put on the diagram. I don't know, it might help, right? That's it. So the answer is 70 degrees. Next one. Calculate the length of OR. Where's OR? OR is right here. OR. But remember that this length is 15. So we can use that right angle triangle. Because they said it's a rectangle, you know, don't it? So that's a rectangle, then this angle down here is 90. It only says 90 degrees. See, they say it's a rectangle. That's what they said up here. So it means that this triangle now is a right angle triangle, this one. And once you have a right angle triangle, you can use Pythagoras theorem in it. And remember also that this side is 15 over here, so it's 15 meters. So to find OR down here, you're going to use Pythagoras theorem. That's a hypotenuse, right? So using Pythagoras theorem, the OR It's going to be the square root of the hypotenuse squared, that's 15 squared, minus this side over here squared, 14.1 squared. But I understand that Pythagoras theorem, Pythagoras that, that's not the only way to do it, but okay, we'll do it this way this time. Pythagoras theorem says the square root of 15 squared minus 14.1 squared. That gives us 5.12. So OR becomes 5.12. Street significant figure is 5.12 and it's meters. Everything in this question is in meters. We're working in meters. That's it. Next part now says, calculate the area of the shaded portion of the diagram. So when the area shaded here, so now. So we can find the area shaded is to find the area of this triangle in the side or so, and find the area of this semicircle. All right, and we can find the area of this triangle. We can use the trig form for area of a triangle. Half the sum of these, half the product of these two sides, times the sine of the angle between them. You must know your formula, guys. And then the area of a semicircle up here, so it's just half the area of a circle. All right, so the area shaded is going to become equal to half the 15 times the 15 times the sine of the angle between them, which is 40 degrees, plus the semicircle, which is half the area of a circle. Area of a circle is pi r squared, so this is half pi times the radius squared. Now, what is the radius? The radius of this semicircle is the same length down here, so we was find a while ago, the OR. See, it's the same length here, so. Right? So the radius of this circle is same as the OR down here. Same radius that they have up here, so. So that's what we realize. That the radius of this circle, this semicircle, is equal to the OR that we just calculated down there. Which was what again? It was 5.12. 5.12 meters. All right, how am I getting this area? Using the trig formula for the area of a triangle. Half the product of two sides times the sine of the angle between them. All right, so this becomes half. This becomes half the 5.12 squared. I'll write some formula piece for you about it. So for this one, we are using half AB sine C formula. For this one, the semicircle is half pi r squared. That's what we're using. So this is the semicircle area, and this is the triangle area. So remember the area of a triangle, guy, I'm going to put it up here for you. You have to know these things. When you have a triangle, when you know two sides, A, B, and the angle between them is C, then the area becomes half AB sine C. The area is half the product of the two sides times the sine of the angle between them. More things you know, the better. Half AB sine C. Actually, on the formula sheet, and see if it's on this formula sheet and show you. So on the formula sheet, see it right here, so half AB sine C. So that's here. We're talking about this triangle. That triangle we're talking about. This angle is angle C. So half AB, and the angle between them is C, half AB sine C. So the formula is there on the formula sheet. So a lot of times, formula there, people don't even know where to use that, know it for. Here it is. What better you know them in your head and not depend on a formula sheet. Anything that's on a formula sheet when you practice it, just know it in your head and you say you need to know it. They don't put on a formula sheet, it means that they need to know. You should know every formula on the sheet. Every formula on the sheet, you should just know in your head. So you don't have to depend on the formula sheet to do it. Just know them. I know what happened. So you see the formula is there on the sheet. I'm not pulling it out of any hat or anything like that. Applying something that you're supposed to know. Trig formula for the area of a triangle. When you know two sides and angle between them, you can find the area that way. And don't mess with it any other way. Any other way is harder and longer. Do the easiest way possible. That's it. Put all of this in the calculator and you get the area. Shaded portion. Just put everything in the calculator. All right. In this exam, in this case, The A and the B is 15. See it here? See the triangle here, so? Focus on this triangle. That this is A and this is B, and this angle between them is C. So the A is 15 and the B is 15. And the C is 40 degrees. See that? Half AB sine C. We use it. Come on, man. All right, that's what we're using down here. So let's put everything here so in the calculator now and get the answer one time. You want to get the answer the easiest way possible, you know. All right, so ready now. So it's half, same as 0.5 times 15 times 15 is 15 squared times sine of 40 degrees, sine of 40 degrees. All right, make sure you calculate the degrees. Then you're going to add half the area of a circle, 0.5 again, times pi. If someone use 20/7 for pi, yeah, let's say use 20/7. So let's make sure we use it. 20/7. So we're going to put 20/7. And you multiply that now by 5.12 squared. And that gives you the answer one time. 113.5 meters. Meters squared. Or we can just put 114 meters squared if we go in three significant figures. 114 meters squared here. Very good. Very good. You can fast. Then the perimeter of the shape. Perimeter of the shape, they want now. PM, to make sure, now the shaded region, I want the perimeter, the whole shape. PMQROS, let's make sure. PMQROS, they want to air the perimeter all the way around here. So let's look at it now. So this length, so the length across here, so now, remember, length across here, so now is 2 of this, now. Half of this was 5.12. Let's put on the diagram. Remember, we work this out, that's 5.12. Right here says 5.12 meters. So over here says also 5.12 meters. Yeah, leave it now. All right, tomorrow. All right, good. Monday. All right, 5.12 meters. Remember, this length and this length is the same. That's 14.1 over here, so 14.1 meters. And then we need this arc length. We need that arc length. Now, the circumference of a circle is 2 pi r. This is half of it, so this length is just pi r. Circumference is just pi r. Good? Pi r. The radius of it is that. But the circumference, this length around, half of that is just pi r. So this plus this, 2 of that, 2 of the 5.12, and then the pi r up here. But I say that, give us the circumference, right? Let's write it down yesterday. So the circumference of the perimeter becomes 2 times the 14.1, 2 sides, plus 2 times the 5.12, plus the pi r up at the top. And the r was what? The r was 5.12 as well. That becomes your perimeter. All right? Let's write what this is. This length is pi r for the semicircle. So the 2 sides, length at the bottom, 2 halves at the bottom, and the curve at the semicircle at the top. What can I say that? What I say that? Good. Put everything in the calculator and you're good to go. So this works out to be. Let's make sure the figure is 14.1 and 5.1, right? 14.1. So it's 14.1, 14.1, 5.2, 5.2, and then the arc length up here, so it's pi r. 2 pi r will be a full circumference, that's half of a circumference, so just pi r. All right? So let's put this in the calculator. So it becomes 2 times 14.1 plus 2 times 5.12 plus pi. James must put as 22/7.
So you're not gonna put in the brackets.
Huh?
I go put in the
You know
bracket.
what?
Brackets.
Don't put the bracket. No, it's same as times. Don't put the bracket, same as times. Don't put the bracket. Same as time. This is same as 2 times 14.1. This is same as 2 times 5.12. Same thing. So that's 22/7 times 5.12. Take more time to put in bracket, believe me. Let us put times. That's 51.5, 54.5, 54 1.5 meters is the perimeter of that. Nice, easy 3 marks to get for that. Quick and fast, nice and easy. But good? But okay? Let's move on. Then we come to the pattern question now. It's going to finish this question like in 5 minutes on the exam paper. The easy ones. It says the sequence of figures is made of rectangle of regular pentagon using sticks of unit length. The first 3 figures of the sequence shown below. The vertices of each stick is marked with a dot. And I say an incomplete diagram of figure 4 in the sequence shown below. Complete it. So we need to add on one of this onto it. Right? Don't know. So you see they keep adding on a thing onto each one. So they added on this to this, and they added on this to that. So let's draw what we're adding and copy it though. I want to use the device. So we're adding on this shape. That's what we're adding on. And we're adding these dots. That's what we are adding to the shape down here now. Bang. And we are done. See that? So that's what you need to draw an exam, guys. That's what you need to add to the shape to complete the shape, right? Figure 4, done. Next part. Next part now says, study the pattern of numbers in the row below. Each row relates to one of the figures in the sequence. Some rows have not been included, and I want us to complete the rows 1, 2, and 3. I would like to use the formula row first because it helps up the top sometimes. All right? So what's happening here? Keep adding 4, right? Plus 4. Plus 4. So the formula starts with 4n. But the first figure actually has 5. 4 times 1 is 4. If I add 1 to make it 5. If you're not sure, you can try the formula on the second one when n equals 2. 4 times 2 is 1. 4 times 2 is 8. 8 and 1 make 9. So you know, so the formula works. All right? Formula works. Then for this one now, this is what? They're adding 3 plus 3 plus 3. So because they're adding 3, 3n starts a formula. But the first figure has 5. 3 times 1 is 3. I have to add 2 to make 5. So the formula is 3n plus 2. If you're not sure, try the second one on it. 3, 2 is 6. 6 and 2 is 8. I can try the third one on it. 3, 3 is 9. 9 and 2 is 11. So you know that the formula works. You're good to go. Formula works. Then for here now, all that happens here now, the n is 20. They take the 20 and drop it on that. 4 times 20 is 80. 80 plus 1 is 81. So it becomes 81. 81. Then drop the formula on this again. 3 times 20 is 60. 60 plus 2 is 62. So right here says 62. Then for here, you want to find the n for here, put this equal that to find the n. All right, to find the n over here, you put the formula equals 169. So right here, we're going to put the formula equals 169. So we're going to put 4n plus 1 equals 169 right here. Subtract the 1, we're going to get 4n equals 168. Divide by the 4, we're going to get n equals 42. But I get that? N equals 42 right here. That's correct? And you're going to take the 42 and drop it on this formula now. So it help you when you have the formula, right? So here now, we're going to use the formula and put 3 times 42 plus 2. What I work out to? 128? 128. Yes, that's 120 plus 6, 126 plus 2, 128. Good. That's it. It says, write an equation in S, D, and N to show the relationship between the number of sticks S, the number of dots D, and the figure number N. So they want a formula connecting the 3 things. Remember, the S is equal to this. Okay, write that as one equation. So the S equals 4n plus 1. And the D is equal to this. The D is equal to 3n plus 2. Now, the interesting thing about this question is that them say write a relationship, write an equation connecting the 3 variables. So you can make the sum of the values, the difference of the values, the product of the values, the quotient of the values, your choice. Right? So if I'm going to use sum, I can add them. All right. S plus D equals. Add them two, so I get S plus D. Add up the side here. So the 4n and the 3n is 7n, and the 1 and the 2 is 3. That's one formula. I could subtract them and do S minus D. So the 1 here minus the 1 there. So it will be 4n minus 3n is n. And then 1 minus 2 is negative 1. That's another formula I could get. I could multiply them and say, okay, S times D, SD. So SD will be the 4n plus 1 times 3n plus 2. If I multiply them, I could divide them and do S over D. S over D will be 4n plus 1 over 3n plus 2. So it's really your choice what you want to do. Whichever one you want. Because it's a formula like all of them. But what they have sometimes is to get a relationship between the S and the D alone without the N. So they want a relationship between the S and the D without the N. Then you want to eliminate the N out of these two. So what you could do to eliminate the N out of these two, and that's if they wanted a relationship without the N. Without the N, right? So if you want without N, I just want a relationship with the S and D alone. So you want without N. Without the N. You want to form a relationship without the N, just S and the D alone. You could make the N the subject of this one, and it would be that the N would be S minus 1 over 4. But you can see that? You over the 1 first, you get S minus 1 and then divide on the 4. That's for that one. And then for this one, it would be that the N equals Q over the 2, you will get E minus 2 over 3. And then if N equal this and N equal that, you could join them, join the two of them, and then you will get this equal this. So you could get S minus 1 over 4 equals E minus 2 over 3. You could actually do that. Right? And that's a relationship with the two of them. You can also simplify, cross multiply and simplify. So I multiply the 3 over this side, I multiply the 4 over this side. I would get 3s minus 3 equals 4d minus 8. And then if I carry the 8 over here, just to simplify it, I will get 3s plus 5 equals 4d. So that could be a relationship between the two variables without the n. So I don't know what CSEC would ask you. I'm just doing this one for Barata, right? In case
Wait,
they ask
sir.
you that. Yes?
So
So it's one of these is the answer, doing it. One of these is the answer based on this question. One of these is the answer.
so any of them could be the answer.
Any one of these. Any one of them you want. Anyone. Choose one. Anyone. Anyone. Use any one of these based on this question. Use any one of them. Use any one of those. But I'm just telling you now, if they wanted an equation without the n, this is how you could do it. Get a direct relationship between the x and the d. Make n the subject of one of them, make n the subject of the next one, and then equate these two things and simplify. Or if you could substitute for the n from one into the next, they could do it as well. Use an elimination method, get rid of the n. Right? If they wanted an equation without the n. So this is just something extra that you need to guys. Put that if in front. If they wanted an equation without the n, that is what you could have done. If, as I've seen them ask that already, a relationship without the n, relationship between the two of you, so eliminate the n. But that's it. But you can use any one of these for your answer, right? Any one of them could work for your answer. All right, add them. That's why they say an equation. An equation. So everybody's answer might be different. Some people might choose to add them, some people might choose to subtract them. Some by choose to multiply them, some by choose to divide. Those are the operations that we are used to. Add, subtract, multiply, divide. Those are relationships with operations that we are familiar with. So one of those four. Add, subtract, multiply, divide. So I'll give you all four. Let's continue. Number 8. Number 8. So number 8 says the diagram below shows a graph of the function y equals x squared plus x minus 2. And they give us that graph, right? So that asks us something about it. Now, what are the roots of the function? The roots are where the graph intersects the x-axis. Roots are points on x-axis. All right? Points on x-axis. And you want the x values on the x-axis are the roots. So here and here are your roots. See that? So these are
1
your
and
roots.
-2.
Yes, -2 and 1. So these are your roots right here. This is one root. This is the other root. All right? Root and root. So it's x equal -2, x equals 1. So it's x equal -2, x equals 1. Next one. The coordinates of the y-axis intersect. And so the coordinates mean plural. On the y-axis, the x value is 0. So I put 0 on the y value. And the question said coordinates. You cannot put the y value alone. So 0 what? On the y-axis, 0 what? 0 something. On the y-axis, 0 something. Where is it? Y-intercept. Right here, the y-intercept. Right here. It's a y-intercept. So that's 0, -2, guys. 0, -2. 0, -2 is a y-axis intercept. Next one. The minimum value of the function, lowest y value in the function. Lowest y value in the function. What's the lowest y value right here? Looks like, sorry. The lowest y value right here looks like -2.4. I'm going to say 0.4. Because the interval here, so, is already. So the interval right here, so, is 0 to 2, right? And there are, let me put it this way. Up here, so, is 0 to 2, and there are 5 intervals there. So each of those little lines is 2 divided by 5. 2 divided by 5 is 0.4. So it means that each of these little lines is 0.4. So right here, so, looks like -2.4, don't it? Don't it? But -2.4 is not correct. I think if you put -2.4, they'll give you the marks and the exam. But in reality, the minimum value can work it out using YT. Remember XCYT? So the safe thing to do is to work it out. The minimum value is your YT value. The minimum value is your YT value from this function. The minimum value is a YT value. The minimum is YT. Or YT equal again. 4AC minus B squared over 4A. What is the A? The A is equal to 1, the B is equal to 1, the C is equal to -2. Let's work it out. YT equals 4 times A is 1, times C is -2, minus B. The B is 1 squared, divided by 4A, 4 times 1. All right? That's the YT.
Wait.
What is work out?
Wait, so you mean K?
K, yes, same as K. Some teachers call it K. Some teachers use K. Yes, same as K. Same K, same K. Same thing. So the Y value at the turning point, we call it YT in this class. It is a Y value at the turning point. T means turning point. That would be -1. Somebody wrote that word for me. So that would be a fraction. This 4 times 2 right here, so it's 8. That's -8. Minus 1. So the 1 squared here, so it's 1. So -1. And you put that over 4. 4 times 1 is 4. So you get -2.25. See that? -2.25. That is the correct answer. I don't know if CSEC want the correct answer. I don't want what the graph showed. See me? Because I can't see this on the graph. The graph looks like negative 2.4. Where you put? This, you work this out? Huh? You do? Where you do? And you put what? Negative 2.25? Really? You know, see negative 2.25. But go by this interval. This other negative 2.4, my boss. Negative 2.4. No, this is not 0.25. Each of these intervals cannot be 0.25, my boss. Cannot. I don't show you. Each of those intervals has to be 0.4. I don't show you a while ago. I don't show you. Right? You buck up on it. Okay, look here. There are 5 intervals up to 2. So each of them is 2 over 5. Each of these lines is 2 over 5. Look. Look. Look, look, look. Prove it to you. It's a 0.4, 0.4. It's a 0.8. It's a 0. It's a 1.1.2. I add 0.4 to that. It's a 1.6. Next one a 1.6. 1.6 plus 0.4 reach 2, see? So each of those little line is 0.4. So if you look on the graph, you're on this line. The midpoint is on this line. The minimum point on this line. So it's negative 2, and then another interval will be negative 2.4. See that? Correct answer is negative 2.25. So I guess anyone they give it a marks, right? I think if you put negative 2.4 based on this graph, they'll give it a marks. But we have that knowledge about how to calculate it and the graph. You see, with these small intervals, you can't see 0.25 different from 0.4. That's a point. You cannot see the difference between 0.25 and 0.4. But the interval is too small. And the fact of the matter is that the graph has to be drawn with thickness. Because the graph has to be drawn with thickness for you to see. You cannot see those little small unit of measure, those small intervals of measurement. All right. So if I'm in the exam, I'm going to give them this one. I don't care. I'm going to show them this calculation up here. And them say use the graph, you know. That's a sad thing about them. Say use the graph. Say from the graph. See? That's a from the graph. So I'm going to tell them this one down here. So I'm going to say correct value is negative 2.25 for the graph. Minimum negative 2.4. Both answers are there. You have to mark it. You know that if you put 2 answers on the paper, once the correct one is there, you have to mark it. You know that? Right? So if you're not sure about 2 answers, but they leave it 2 of them on it. Once the correct answer is on the paper, you have to mark, you have to give the benefit of the doubt. Have to. You have to give you the benefit of the doubt. All right? Telling you. This get thicker. Hold on a second, guys. It's a perfect. All right. That's it. So any one of those two you give would be the answer, right? The equation of axis of symmetry, that's your xt value. And you can actually see it right here. Clearly, you're right in between you, so like negative a half, you know. You're right here, so. See, your vertex point is here, and that vertical line is minus a half. See, between 0 and negative 1. Minus a half. But can work out again. It's worked out again up here, so xt. It's x by the turning point. So we calculate xt up here, so xt, x by the turning point is minus b over 2a. Minus b over 2a. Minus b over 2a. And the b is what again? The b is 1, right? So it's minus 1 over 2 times 1. And the A is 1. See, minus a half. Minus a half for real.
Is that
Become,
H?
that's minus H. If you learn it to the plus H method, it becomes minus H. It becomes minus H.
I'm trying to find the minimum point now, sir.
If you use the HK method, it's minus H. And the minimum point used in the HK method is minus H, minus HK.
Oh,
And then this becomes the axis of symmetry. When my class, we use XP, we call it XP. It's a different approach, right? So that's it. So if you learn with the H, it will be minus H. And assuming that your function is A into X plus H squared plus K using that method, then it's minus H. You use it, minus H. All right, but we don't use that method in this class. But anyway, it's XT down here, so the equilibrium axis of symmetry is X equals the XT value. X equals X by a turning point. X equals XT value, which is X equals minus H. It's the axis of symmetry. Yeah, that one obvious on the graph, you can see. Next one says no. On the same pair of axes, draw the line y equals 2x plus 4. So this line, for us to work at 4 and to a gradient of 2. For us to work at 4 and to a gradient of 2. Let's draw it quickly. Let's draw it in the ring. Let's draw it in the ring. So you cross the works at 4 and to the gradient of 2. Gradient of 2 means rise 2, run 1, right? If the gradient equals 2, then we can rise 2, run 1. Rise 2 and run 1. So from here we can rise 2, run 1 to get to other points. So rise 2, run 1, Mr. Shaw. Rise 2, run 1 to here. And rise 2, run 1 to here. Let me see if that's 1. Yes. This is that was 2x plus 4. Sure. 2x plus 4. All right. Rise 2, run 1. And then down here, so now you can also rise -2, run -1. So you come back down 2, go back -1 to here. Come down -2, go back -1 to here. So those points are on the graph. I was hoping that I will get 2 points of intersection. So they want us to do it after we do it. You must see. Them say use your graph, determine the solution, the pair, something wrong, something wrong, because not intersecting at 2 points. Should intersect at 2 points. Because this means that they want 2 points of intersection. But they're not intersecting on the graph. That's a plus 4. Again, this 2. Let's plot 2 points. Let's plot 2 points. So 1 point clearly 0, 4. 0, 4 is 1 point. And if you give x a value of 3, for example, you're going to get 3, 2, 2, 3, 6, 6, and 4 is 10. So you pass through 0, 4 and 3, 10. So you pass through 0, 4 right here and 3, 10. Pass through here, so somebody do something wrong. Rise 2, run 1. Oh, see the mistake now. See, I'm riding grid. See it? So I'm careful. I'm rising grid. This is rise 2. From 4 to 6 is rise 2. All right. That's the mistake. So see? I am doing what I always tell you not to do. Don't rise grid, right? You rise units. You don't rise the grid. The vertical scale and horizontal scale different, guys. That's what happened here. And say next thing, when you're doing foolishness, you must know. It's the next thing. All right, so this is actually rise 2. From 4 to 6 is rise 2. But horizontally, that grid is 1 unit. So vertically, 1 grid is 2, but horizontal, 1 grid is 1. So rise 2, run 1 to here. That's there. Rise 2, run 1 to here. Rise 2, run 1 to there. See it? Rise 2, run 1 to here. So all those points are on the graph. And then go the other way, rise 2, run, rise 2, rise -2, run -1. So rise -2, run -1 to here. Rise -2, run -1 to here. Rise -2, run -1 to there. Rise -2, run -1 to there. So all those points are on your line. All those points are on the line. So the straight line through those points is your line. So I'm going to draw it like this. This vertex, this vertex.
Actually, I'm confused. What was the mistake you made?
Huh?
I'm confused, sir. What was the mistake you made?
I was using rise as one grid. I was using rise 2 as 2 grid up here, so. But 2, but that is not 2. 2 is this. From 4 to 6 is 2. But run 1 across is this. So I see horizontally, 1 is 1 grid. But vertically, 2 is 1 grid. See that? I'm not supposed to rise grids. I'm supposed to rise units. You understand that now?
Yes, sir.
Good. I'm not supposed to rise grids. I'm rising units. So vertically, it is 1 grid. It is 2 units, but horizontally, 1 grid is 1 unit. So that's a difference. So I have to be careful. So let me see if I can draw this line now. Not going straight at all. Straight here. All right, that's it. I can extend it out to here. All right. So I know they're gonna ask us about these 2 points. They must ask us about these 2 points. And these 2 points now will be the points of intersection of the line and the curve. So right here is a point 310 where they intersect. And right here is the point -20. -20. So on this side. The root point, -20. That's where they intersect, right? Let's label the line. The line is y equals 2x plus 4. All right. So we have drawn the line there, guys. We have drawn the line. And then down here now, they said, use the graph, determine the solution for the pair of simultaneous equations at the points of intersection. This one's the points of intersection. Point of intersection. Which we said was -20 and 310. That is the answer. -20 and 310 are the solutions. What about that? Those are the solutions. So this will be x equal -2, y equals 0, one pair, x equals 3, y equals 10 will be the other pair. For solving those 2 equations simultaneously. Because solving simultaneous equation is the same as basically the points of intersection on a graph. So that is it. All right. Question done there. So next part says, following
Yes, so the
diagram.
points of intersection.
Huh?
No,
Yeah,
sir.
man, when you solve simultaneous equations, you really find the point of intersection. So if you have the graph and they ask for they say use a graph to solve these simultaneous equations, you are really finding with the line and the curve occur at the same time. That's what simultaneous means. Right? That's what it means. Where the curve and the line intersect each other, where they are at the same time, at the same place. So that's what these 2 points. Those are the points where the line and the curve meet. And you solve the equation simultaneously, those are the points you're gonna get. All right, so that is it.
So you're not going to put in the value in there and
No, I'm done. This is the answer.
okay.
You don't have to solve it. You say use the graph. And the graph shows you the points. Where they intersect are the points. You don't have to do anything. This point where they intersect is 310. See there? 310. And this point where they intersect is -20. So those are the answers. That's it. They're done. No calculation are needed on this. I bet you 1 mark for it. Much marks for it? 2 marks. 1 for each. That is it. Right? Point of intersection. You have to know that when you solve equations simultaneously, that's what you're actually doing. You're finding points of intersection. So it's like we do a graphical method. You have a calculation method when you work it out, but what we do on the graph now is a graphical method. So when you find the points of intersection, That those are the coordinates. If you solve these simultaneously, those are the answers they're gonna get. But the graph show you, so you have to work it out. That's what it is. The graph shows you. And so you don't have to work it out. The graph shows you. All right. Down here now. It says the following diagram shows the velocity time graph of a car's journey from town R to town Q. All right. So remember, it's a velocity time graph. Remember, the key thing on a velocity time graph. Gradient is acceleration. Area under the graph is distance traveled. Gradient is acceleration. Area under the graph is distance traveled. All right. It says the car accelerates for 2 minutes, and the 2 minutes is 120 seconds, right? The 2 minutes here is 120 seconds because this horizontal axis is in seconds. So that is correct because each of these grids is 60. So this is the acceleration that I'm talking about up here. So this acceleration up here. So and for this time down here, so which is 120, right? It's over 120. All right. So they're talking about this little section here. This is 120 right here. 120. But each of these little grid now is 60 seconds. So the first part is mentioning this acceleration up here. This acceleration up here. Up here, so. But 120 seconds, 2 minutes. That's what I'm at 120 seconds. That's 120 seconds. Then it travels at a constant maximum speed. That's up here now. It travels at a constant maximum speed of 30 meters per second. That's it. All right, up here, the acceleration is zero. Acceleration is zero. The speed is not changing. It's going at a constant speed. Right? And then it slows to stop. So this is when it's slowing now. It slows down here. And down here, so now it's stop. Down here says when it's stop. Or is it at rest? Because the speed down here, so it's zero. All right? So just highlighting those things on this graph. All right, that's what I want us to do now with that speed time graph. It says, determine the initial acceleration. Initial acceleration is the gradient of the first section there, so. Acceleration equals gradient, or you can say the rise gradient. It is the rise gradient. Deceleration is the fall gradient. Over here, so it will be deceleration. The one to the deceleration, it will be the fall over the run, the fall gradient. Acceleration is the rise gradient. The rise over the run. The rise gradient is acceleration on a speed time graph. So we're looking for the rise gradient. Our increasing speed, accelerating. And the rise is 30. And the run is 120. See? It's 30 meters per second over 120 seconds. Let's put in the units. 30 meters per second over 120 seconds. So that becomes a quarter. 1 over 4 meters per second squared. I can write 0.25. 0.25. 0.25 meters per second squared. That's a second divided by a second, give you the second squared. All right, that is it. Next part now says, calculate the distance between the two towns. Distance equals area under the graph. Distance equals area. Area on the graph. Area on the graph. Give a distance on a speed time graph or a velocity time graph. What's the area? What shape is this thing? This is a trapezium again. This is a trapezium. This shape is the shape of a trapezium, guys. So the parallel side here, so up here, so up here, so. All right? So the question is now, what is this length out here, so? What is this length out here, so? This length out here, so is 60 more than this. That's what this is, 60 more than that. So out here, so we're adding 60 to this. So we're getting what? 840, right? So it's 840. What is this length up here, so now? This is between the 120 mark. This mark is what? This mark is 600, right? This is 600. So it's between 120 and 600 is the length of the top up here, so. This length up here, so. 600 minus 120. How much is that? What is that? Minus 100 plus you get 5 minus 20. 540 that, 580 that, right? 580. So that's, and then the distance between the parallel sides is still 30. See that? 30. So using area of a trapezium. So note we're using the parallel sides of 840 down here, so, and 580 up there, so. And then the distance between the parallel sides down here, so now, is 30. 30. So those are the dimensions we're using for this area. 8, up here, so? Yeah, 600. Because remember now, right here, so. Right here, so. Right here, so is at the 600 mark. And right here, so is at the 120 mark. See that? What again? It's 480. Oh, it's only tell me. Oh, yeah, 480. My mistake. 480. 480. All right, good. 480. It take long for see that, team. It takes a long for see that. All right, 480. All right, that is it. So this length is 840. Up there, so it's 480. Yeah, you minus 100 first, you get 500, minus 20 more. 480, good. And then now, this time between them is 30. So we're in 840, 480, and 30. Ready? So that becomes equal to half the parallel sides of 480 and 840. And the distance between the parallel sides is 30. Work that out and you get the distance travel, which is the area. So it becomes half to 0.5 times a bracket of 480 and 840 close the bracket times 30. That's 9,800 meters, the distance between the two places. Meters is the distance. And even when you calculate that area, guys, don't put meter squared. Remember, the 30 is in meters per second, and these times are in seconds. So the seconds cancel, leave you with the meter. All right? That is it. All right, good. Almost messed up that one. So there you go. Next question. Number 9. It says a ship sails from A to B. From A to B. 15 kilometers on a bearing of 040 degrees, 042 degrees. Let's put them on there. So remember, bearings are direction, give in terms of an angle, clockwise from the north direction to the direction you want, right? So that 42 degrees that spoke about right now is right here. So that angle is 42 degrees. So you can put the 042 on it if you want. And this distance is 15 kilometers. And this point is point B. This point is B. Up here, so is the point B. All right, what else? It said the ship then sails to point C, which is 19 kilometers away. But this distance on us is 90. Let's put it on there. 19. Let's put it on there. This is now 19 kilometers down here. On a bearing of 130 degrees. So the bearing of this direction is 130 degrees. So clockwise from the north direction, that angle is 130 degrees. Let's put it on there. 130 degrees. Let's put it on there. So this angle of this direction, expressed as a bearing, is 130 degrees. 130 degrees is that bearing. The bearing of this direction is 130 degrees. That's a diagram, right? It says the following diagram is a sketch of the journey. See here on the diagram, insert the 040 to 2 degrees and the 130 degrees. See them there? 42 is over here, the 130 is up there. Next part now says calculate the distance between the two towns, A and C. That's this distance I want. C is down here, so C is down here, so. This point down here, so is C. And they're asking us for this distance. So to find that distance, we need the angle between here. So we can use cosine rule. Find that angle, multiple ways to find that angle, but for me, the easiest way to find it is to, let me show you now, is to do what? Is to break it with the vertical line like this. Extend this knot line down. Extend this knot line down here. And this line and this line parallel. And so if you join them here, you have Z angles in this side, yes or no? Z angles. So them two angles are equal, right? That's the first thing. So that angle inside this is same as the bearing angle. So this angle inside this is 42 degrees as well. Because of the Z angles. And then on this side now, that's total angle on a straight line is 180. And if up to here, so it's 130, then the angle inside here, so now the remaining angle inside here so must be 50 degrees. And therefore the angle across here, where you add them up, it becomes 92 degrees. And when you know that that's 92 degrees, you can use cosine rule now to find the side across here. Cosine rule. So let's do it. But I say that, but I go to that. That's not the only way to do it, but for me, that's the easiest way to do it. All right. So we're going to use cosine rule for that distance AC. So cosine rule for AC. Cosine rule for AC. Remember, cosine rule starts out like 5,000, as if this was an hypotenuse and that was a 90. That's how it starts out. So it starts
Wait,
out
sir.
like, yes,
Sorry, could you tell me how you got the 50 degrees again?
the 50, because total along a straight line down here, so it's 180. And up to here, so it's 130. So the remaining piece in here, so must be 50. See, 50 and 130 makes 180. See that?
Oh, okay.
Good. All right. All right. So start like part out the shape. AC squared equals this side squared plus this side squared. If it was Pythagoras' theorem, 15 squared plus 19 squared. But it's not Pythagoras' theorem, so you have to subtract a piece. Where you subtract? What's the product of these two sides? The 15 and the 90. And then you cosine the angle between them, which is the 92 degrees. 92 degrees. That's cosine rule. Starts out like Pythagoras' theorem and then you subtract a piece like that. But instead of squaring this side, we could instead cancel that square by square rooting and then square root that side. And then get the AC in one calculation with the calculator. So AC equals now whatever this works out to be. And nobody waste time working out your piece by piece. You're not getting the marks for that. Just put everything in the calculator one time and get one answer. Don't waste time. Use the full capacity of the calculator. So square root of 15 squared plus 19 squared minus. So I put in the brackets, I'm going to put 2 times 15 times 19 times cosine of 92 degrees. And it's 24.6. 24.6, and that's kilometers. 3 significant figures again. 24.6 kilometers is the length of this distance here, so. All right? And as you find it, you put it on the diagram in case you need to use it. The equal in front of it since we worked it out. So this side equals 24.6 kilometers. What good at that so far? What good? Let's make sure that those values in the calculator properly. 15, 19, 92. Good. Next part now says, calculate the bearing of tone A from tone C. Always note the from position. So we're going from C to A. So one the bearing of the direction C to A. Remember, bearing is a direction. Let's look at how we can find it now. So we want the bearing from C up to A. So like you want the bearing of this direction. So bearing of that direction, the paper not so friendly. But it will be the clockwise angle around here, so. Around here, so. To this direction. That's the angle that you want. I want to show you something now, guys. You can work it out here, so now. To work it out down here, so that angle, what we'll do, we'll find the angle inside here, so using cosine rule, using sine rule. And then this angle will be 50 degrees. Why is this angle 50 degrees? One because of the Z up here, so. Or we can say these two angles are up to 180 because of their co-interior angles. So this angle here, so it's 50 degrees. So if you sine wave and find the alpha, it will be 360 minus the 50 and minus the alpha, right? Leaving that for you to go home and do. I want to show you something else to find the bearing another way. More mass equals better mass. Watch this now. So the bearing of this direction here, so, is the same direction if I come up here, so no. It's the same direction over here, so. So I can actually find the bearing at this point. Same here, because the same direction. So I can find the bearing from here so to here, so it's the same direction. See that? And that bearing would be this angle now. Watch. It will be this angle over here, so I'm going to mark it in blue. It will be this angle around here, so now. All of this. So we can find a blue angle there and get the same answer. That blue angle. And that blue angle, I would need the angle inside the triangle. I'm going to mark it in purple. Let's call it beta. And so that blue angle would be equal to, look at it now, look at the part of it. Equal to the 42 right here, so. The beta in there, so. And 180 degrees out there, so. See that? But I can see that? That blue angle, let's look at it again. That blue angle is the bearing of that direction, same way. Even though we're not finding it down at this front position, you can find it anywhere. Once you're finding it off the direction. So we can actually find the bearing here, so as well. We don't have to find it down here, so. I'm challenging you to go and find it down here, so. I just explained to you how you could do it. But I also wanted to show you that you don't have to find it down here. It's the direction you want. Right? So, look at it again now. That blue angle is the bearing of that direction up here. So, which is direction from C to A. The same direction is the direction from C to A. Same direction. C to A is still this direction, pointing in that way. And I'm saying it's that blue angle, clockwise from the north line to that direction is that blue angle. What makes up that blue angle? The 42 degrees here, so. The beta in here, so which we're going to have to work out. And then the total angle on the straight line part is 180 degrees. So it becomes 42 plus beta plus 180 degrees. We have to go work out the beta using sine wave. But can I say that? But say that? So let's do it. Let's do it. So we have to work out the beta using sine wave, right? All right. So we're going to say that bearing angle, let's call it theta on the diagram. That bearing angle is theta. This blue angle is theta. And that blue angle, we're going to say it is theta right here, so. And the theta, say, becomes 42 degrees plus beta plus 180 degrees. And we're going to use sine rule for the beta. Sine rule for the beta angle. So we use the sine rule now. Sine of beta over the side opposite equals sine of 92 over the side opposite, right? Sine rule. So I'm going to write up where the diagram is and then copy it down. Let's write where the diagram is and then copy it down. So let's write the sine rule for beta. So it would be, let's do it in red. It would be sine of beta, sine rule. Sine of beta over the side opposite the beta, which is 19, equals sine of the 92 over the side opposite the 92, which is 24.6. That's the sine rule. That's what we're going to be using down here. So let's copy it down now and work it out. So I'm putting it here. That's the sine rule. Then now, to find the beta now, we're going to multiply the 19 up here so first, and then take the inverse sign in front of it. So it's going to be that the beta equals sine to the minus 1. This smaller Mr. Shaw, double letter space. So it becomes sine to the minus 1 of the 19 times the sine of the 92 degrees divided by the 24.6. By the time I get that? By the time I get that? By the time I get that, right? Multiply the
Yes,
19
sir.
first. After multiply the 19, I get this in the bracket. And I'm going to take the inverse sign in front of that. Inverse sign, that leaves me the beta. I'm putting this in the calculator now for beta. Put that in the calculator now for beta. One calculation. So it becomes sine to the minus 1 of bracket. And it's 90, I need a fraction. Sorry, I need a fraction. And it's 90 times sine of 92. And you put that now over 24.6. That angle becomes 50.5 degrees. I'm going to use that 50.5 degrees right up here for the beta now, right? Use it for the beta up here, now, right? Use it up here for the beta. So the angle that I want, that bearing angle that I want, becomes theta equals 42 degrees plus, how much is that? 50.5 degrees plus 180 degrees. That bearing angle becomes the sum of those three angles. So I'm going to add the 42 and add the 180 with this. I'm getting, what is that? What is that I'm getting? It's forget. So it's 42 plus 50.5 plus 180. So it's 272.5 degrees. But because it's bearing, just tell the church, give it to 3 digits. Correct to 3 digits. So I'm going to write 273 degrees is my answer right there for the bearing. Very good. So if we do it on the other end, you're supposed to get the same angle, guys. If you do it on the other end, you get the same angle. All right, I want you to go and try to say it on the other end. All right, try it on the other end. And it's same answer, same answer. So try that for me when you go. I showed you how to do it already. You know. If you do it on here, so I'm show you one more time. Get this angle around here, so to that. You need a 50 degrees in there, so. Why is that 50 degrees? Because these two angles add up to 180. They are co-interior angles. And then you need the angle inside here, so the alpha. I can show you, look. Can I show you now? Because I know that I know the beta. Can say total angle triangle and find this angle. So let me show you. You can fast since you're on it. So this angle inside here, so would have been 180 minus the beta and this, right? Let's work it out. What is this again? 50.5, right? So that green angle that I'm putting in now would be 180 degrees minus 92 and minus 50.5. It will be 37.5 down there. So this will be 37.5 degrees. So you see that blue angle here, so now it will be 360 minus them 2 here. 360 minus those 2. Let's test it. That blue angle will be 360 degrees minus 50 and minus 37.5. See there? 272.5 CME. See it? What is that? CMT, 272.5, which we're going to just call 272.5 degrees, which is called 273. So you see it could work. This angle becomes that because the beta is 50 point something. All right, so it shows. It's the same. All right, Sasha, not telling that line. Let's go. Next question. Part B, circle theory. It says, points L, M, and P lie on a circumference of a circle whose center is O. The line NP is a tangent, that's a tangent. So once you see a tangent, you're thinking tangent and chord, tangent and radius. All right? Remember, tangent and chord equals angle subtended by the chord, tangent and radius is 90 degrees. All right. And it says this is a straight line from the center there. So this is a right angle triangle right now. This is a big right angle triangle. You know, right is at 90 degrees, right? Just picking up those things as you go. So it says PL is a diameter. Remember, angle subtended by a diameter is 90 degrees. So right here, so now it's 90 degrees over here, so 90 degrees. Angle subtended by a diameter is 90 degrees. All right. And then the angle here is 24 degrees. The angle in between here, so it's 24 degrees. No problem. That's the only angle they gave us. It says, calculate the value of each of the following angles. Show detail working rate necessary and give reason for support the answer. First of all, angle PON. That's angle right here, so them want. Easy. Because remember now that right here says 90. So them two angles here so now must add up to 190 as well. See that? Because that's a right angle triangle, right? So I want to tell them first that that angle equals 90 degrees minus 24 degrees. Because these two angles must add up to 90 because this one is already 90. Right? So 90 minus 24 is how much? 66, don't it? 66 degrees. What's the reason? Because total angle in that triangle is 180. Right? So we tell them this is 90 first. First, we tell them that angle OPN equals 90 degrees because angle between tangent and radius. It's the angle between a tangent and a radius. And then our total angle in that triangle is 180. That's why that's how we do this calculation now. And then total angle in triangle, which one? OPN. OPN is 180 degrees. That's the reason for that, right? So this angle here so now is 66. Let's put it down here. This angle here so now is 66 degrees. 66 degrees. And we find them, we put them on the diagram. They get help you. All right. Next angle I want is angle PLM. Angle PLM. So PLM is this angle here so now. That's angle of circumference. That angle of circumference, if you come back until you find what is subtending it, so you reach a circumference here, come back again till you reach a circumference here, find that that angle up here is subtended by this chord or subtended by this arc. Let's work with the chord. Same chord is subtending 66 degrees at the center. One at the center is twice one at the circumference. So over here, so it's 33. Half the one at the center. See that? Angle that center is twice angle circumference. The angle that we want up here is 33 degrees. All right? That's the center rule. Center rule. Angle that center is twice angle that circumference. So this is 66, this is 90. It's going to be 33. Let's put on the paper down here now. So this angle down here is 33 degrees. It is actually half of the 66 degrees, which is 33 degrees. What's the reason? Angle at center is twice angle at circumference. That is it. Angle at center is twice angle at circumference. Next one, the one. Angle PMN. Where's that now? Angle PMN. 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 The one, this angle down here, son. This angle the one in here, son. All right? So that's an angle in this triangle. So if you can fill out this triangle, we can find this angle up here. So the angle that would need to help us, this angle here now. This angle between the tangent and the chord. And the angle between the tangent and the chord is equal to the angle subtended by the chord up here. So it means that this angle in here so it's also 33 degrees. If you know the 33 and the 24, then we can find this one out here. So that's the premise. That's how we're going to find it. So let's go. So I'll tell them what this one is first. This one. It equals to 33 degrees. This angle in here so it's 33 degrees. Make it bigger.
How is that the case, sir?
Because it is the angle between this tangent and this chord. And whatever the angle is between a tangent and a chord is going to subtend that same angle at the circumference up here. So since the angle up here is 33 degrees, it means that the angle between the tangent and the chord is also 33 degrees. That's tangent and chord rule, or they call it the alternate segment rule. Angle between a tangent and a chord equals the angle subtended by the chord. So this angle out here, so equal that angle here, so 33. Tangent and chord. And then now, if you know that angle is 33, then this angle in here that I want now becomes 180 degrees minus the 24 and the 33. What that work out to? Somebody work that out for me. Oh, nobody never get this. Huh? 180 minus 24 and minus 33. 123 degrees. That's what that is. I'm telling this at 33 down as a first. Right? You can actually put on the paper and so angle MPN is 33. Let's put that first. So this angle said it becomes 123, becomes 180 degrees minus sum of 24 degrees and 33 degrees, which is 123 degrees. What's the reason now? First, going to tell them that angle, what is it again? This angle here, so MPN is 33. Angle MPN is 33 degrees. Angle MPN is 33 degrees. Why? Why is that? Because angle between tangent and chord equals angle subtended by the chord. And then this calculation now, because total angle in the triangle is 180, right? So we're going to say total angle in triangle. What the triangle name? Triangle is MPN. MPN. Total angle triangle MPN. Total angle triangle MPN is 180 degrees. That's how we did this calculation up here, and that's it. End of that question. All right, let's go on to the last question. What time is it? So we're going to 9 o'clock. We'll finish before. So we're not going back. Don't. Let's see if we can finish this question in about 10 minutes. Let's go. This question says, in the diagram, OPL is a parallelogram. So once you see parallelogram, guys, you're supposed to be happy. Because remember, the opposite sides are equal vectors. Them two are equal vectors, and them two are equal. So you populate the diagram. You always like parallelogram questions. But the opposite sides are equal vectors. Let's populate the diagram. So if this vector is R, then the vector up here is also R going up this way. And if this vector down here is S, then the vector across here is also S. Put on everything on the diagram. Easier when you populate the diagram with all information. So you can see how you get around the diagram, right? So this is S, this is S, this is R, this is R, this is S, all right? As a parallelogram. Let's continue. It says OP is R and OL is S. You can see that. OP is R and OL is S. You can see that. All right. Then it says no, T is the point such that PQ equals QT. So PQ equals QT means that these two lines are equal in length and they have the same direction. So it means that the vector out here is also a S vector. So the vector out here is also S. Right here, so it's also S as well. S as well. So it means that P to T is 2S. S plus S is 2S. P to T is 2S. Remember, this level vectors is basically how you go around from point to point, going along the vector direction that you make. All right? That's what it is really about. All right, what else them say? They also said that M divides PL in the ratio 2 to 1. So M divides PL in the ratio 2 to 1. So up here says 2 parts, down here says 1 part. 2 to 1. It means that PM is 2/3 of the whole line. And it means that ML is 1/3 of the whole line. All right? So we have that line broken down to fractions. So we'll find this vector from P to M. From here to here is going to be 2/3 of that vector. And from here to here is going to be 1/3 of that vector. That's how these questions always go. All right, so that's it. So put the ratio on the line so we can see the parts. Then it said, no, find in terms of R and S, means that R and S must be in the answer. Only R and S must be in the answer, the one the vector PL. So we can look at the diagram and say we'll go from P to L, going along the direction that we know. So we can come out here so with the S, and then come down here so with a minus R. We can see that, you know, S minus R. But it could also be O times the last minus O times the first. OL minus OP. See there, last minus first. Okay, we know the two portion vectors. See them here, they gave it to us. So the OL is S and the OP is R. We could see it on the diagram as well. It's S this way and minus R this way. Why is minus R? Because we're going in the opposite direction to the R. That's why it's minus R. So what I want is the diagram or this calculation, same result. S minus R, that's PL. Next part I want is OM. So look at the diagram now. How do we go from O to M? Let's look at it. We go from O to M. We're going to go O to P first and then go P to M. Now remember now, guys. We now know this vector down here, so we now know it. We have it out here now. So because we know it, we can go part of the way if I want, or the part down here, because we now know this vector. So we can go along it now using this, a part of that or the whole of it. So to go from O to M, look at the vector diagram. We're going to go O to P first and then go P to M, where the PM right here is 2/3 of the PL that we know. Let's write it out over here and then we'll copy it down. Let's write it over the diagram in front of us and then we'll copy it down. So we're saying it this way now. To go from O to M on the diagram, we're going to go from O to P first, up here, so with the R. And then we're going to go P to M. P to M right here. But this PM is 2/3 of the PL that we just worked out down here. So instead of PM, we're going to put 2/3 of PL. So OM then becomes OP, which we know, plus 2/3 of the PL. So therefore, we're doing 2/3 of this right here. So if we work it out, this becomes R, because OP is R, plus 2/3 of this now means you're gonna do 2/3 of the S, and then minus 2/3 of the R. And I don't have any space. Let me move this out from here, so. Put it down there, so. Right here, so. Right. So we're gonna do 2/3 of the S and then minus 2/3 of the R. But understand that? That's 2/3 of the PL. 2/3 of this becomes this calculation right here. But good at that. That's the ON. And then when doing these vectors question, you must always consolidate your values. So this is the only S term in there. So we can write that back first. 2/3 S. And then we're doing these two values. So this is like a whole R minus 2/3 R. A whole minus 2/3, 1/3. So you're gonna add 1/3 R. That is it. So O to M is 2/3 S, 1/3 R. We can check if this answer makes sense. Look at it now. Look at the diagram. This is saying to go from O to M, must go 2/3 of a S. So see one S here, so we got 2/3 of the way. 2/3 of the way is about here, so. That's about 2/3. And then we must go 1/3 of a R. So a whole R would have taken us all the way up here, so like this, a whole R. This looks like about 1/3 R for 2. So this is really 2/3 S. And this little short pieces are really look like 1/3 R for 2. Because a whole R will be all of that. Yeah, so this is 1/3 R. So based on that now, we can accept this answer as correct. This answer makes sense based on the diagram. Remember, your diagram and your calculation must always match. Right? The diagram and your calculation must match. So let's copy this down now. This is the answer that we just did for that part. Let's put it down here. It's supposed to be right here. Paste it right here. That's OM. Then it now says, prove that OMT are whole in here, on a straight line. To show that OMT is a straight line, you need to get two vectors between the OM and the T and show that they are parallel and there's going to be a common point.
Sir.
So we already have a vector OM that we can use. So we're going to use that vector OM that we have, OM. And OM is this vector right here, which is,
Sir.
yes?
Sir, is I get 1/3 R?
I'm going to get 1/3 R
Yes, sir.
because it's a whole R minus 2/3. One something minus 2/3 something leave you with 1/3. See that?
Yes, sir.
Good. A whole R minus 2/3 R. A whole minus 2/3 is 1/3. 1/3. All right. So we're using the OM. We need another vector now. So we're either going to use the MOT or the MT. We need another vector with a T in it now. So let's look at the diagram and say which one is easier to get, the OT or the MT. The diagram will look at it and tell us which one is easier to get. So we're using the OM and another vector now, either O or the OT or MT. Two vectors we need. We have one already connecting the O and the M. We need one now. That's either OT or MT. Let's look at the diagram. Tell me which one is easier to find now. See it here now. Either OT or MT. Which one is easier to find based on this diagram? Which one is easier? Yes? OT.
MT.
Nope. OT. Tell people all the while. Shortcutting vectors draw blood. OT is obvious. Or you go from O to T. Or you go from O to T. Come up here so with the R and then go straight across this with the 2S. No calculation needed. R plus 2S takes you from O to R, O to T. Let's look at it again. To go from O to T. Come up here so with the R first. See the R. And then go straight across so with the 2S. That's a 2S. So no calculation needed. It's R plus 2S. But I say that. If you're going to use MT, you're going to have to calculate. You're going to have to do some calculation to go from M to T. To go from M to T. You can't look at it and know. You cannot look at it and just know what it is. You're going to have to calculate. You're going to say, okay, I have to come down here so, and then go up there so, and then go across there so. Or I have to go, come back up here so, and then go across there so. Who want to do that? You have to calculate. The OT is obvious. O to T. See the R up there so, and then straight across there so with a 2S. S and S, 2S. So the OT is easier. But I say that. Do the mathematics the easy way. R plus 2S. So OT is R plus 2S. See there? OT is easier. It is R plus 2S. Get me? The only thing now is that this one has the S in front. So I'm going to turn around this and put S in front as well. So I'm going to write the OT instead equals 2S. So I remember, I need to compare them, you know. So I'm going to write OT equals 2S plus R. And it's still correct, you know, look. Look from O to T. This is saying got 2S out as the same, you know. So still 2S, you know. Same length as that. And then go on R up so. So it's still 2S plus R. See there? 2S out as so plus R. See it? So it's still correct. If you go there, if you think of it that way. Let's go now. We need to now compare these two vectors and show that they are parallel. Now, what do you always say when you want to show that they are parallel? You need to get one to be a multiple of the next. We always try to get rid of fractions first because fractions make it more difficult to see the relationship between the vectors. So we want to get rid of the fractions out of this one. So we're going to multiply it by the lowest common multiple of the denominator, this one with the fraction, which is 3. So we take this vector and multiply it by a 3 to get rid of the fractions, it will eliminate these fractions here. Multiply this by the 3 first, we're going to get 3OM equal. Multiply this by the 3 cancel, we get 2S. Multiply this by the 3, cancel the third and give us R. So you look now, you see that this 2S plus R and this 2S plus R are the same. So if those two are the same, it means that the 3M and the OT equal. So you then can say OT is equal to 3OM because them equal the same thing. So you can equate the two vectors now. You're going to equate the two vectors now. Equate them. We are able to know how to equate the vectors. Equate. So by equating them now, we are now saying that OT is equal to 3OM. That's what you want. And your answer lies now in this statement right here. So now, what does this mean now? What does this mean? These are the two pieces of information that you need for calling your points. They are parallel, firstly, because one vector is a multiple of the next. It means that they are parallel. So the first thing you have is what you want for calling your points, parallel vectors. OT is parallel. Let's write that better, Mr. Shaw. OT is parallel to OM, because one is a multiple of the next. Second thing you need for collinear points is a common point. See there, O is on this one and O is on that one. So O is a common point and the two vectors. O is a common point. And because these two things happened, it means that the points involved are collinear. So you can say, therefore, the points are collinear. O, M, and T are therefore collinear. That's it. And we have the matrices part now, we're done. Matrices part, quick and fast.
Wait, sir.
Yes?
Sir, I just wanted to take a screenshot of the question above here, right here.
Huh?
Okay, you can go
What
to
you
the
say?
other question now, sir.
Huh?
You can go to the other question now.
Which other question?
Question
Oh, you want
after
to go
this
back
one.
up? This?
No, you can go back down. You can go back down now.
Or do this? Oh, you want to take a picture? Okay, no problem. All right, ready now. Three matrices, A, B, and C are such that A is this, B is that, C is that. All right? So this is a 2 by 2 matrix. This is a 2 by 3 matrix. And this one also is a 2 rows by 3 column matrix, 2 by 3 matrix. All right? Let's say must work out AB plus C. So we're going to multiply these two and add this one. Now when you multiply the A times the B, let's see what you're going to get over here. So the A is a 2 by 2. And multiply that by a 2 by 3. So this multiplication is possible because the number of columns in the first matrix is equal to the number of rows in the second matrix. And the result, this equal, so the multiplication is possible. And the resulting matrix will take the number of rows from the first matrix and the number of columns from the second matrix. That's going to be a result matrix. So the result is going to be a 2 by 3 matrix. We multiply the A times B, all right? 2 by 3. So let's do it. So I'm multiplying the AB, which is the 3, 2, 5, 4, by the B, which is 4, 0, 2, 3, minus 1, 7. And you're adding the C matrix, which is this one, which is 4, minus 1, 2, 7, 3, negative 5. We have to do this multiplication first. And I just see we're going to end up with a 2 by 3 matrix. So we're getting back a 2 by 2, 2 by 3 matrix with these values here. And then we're gonna add this other one out here when we're done. 4 minus 1, 2, 7, 3, negative 5. We need to complete this multiplication. Let's work it out in way. Now remember, a multiplying matrix is due to the rows of the first matrix and multiply by the columns of the second matrix. So using these 2 rows, multiplying with these 3 columns, right? So you know which row and which column to use. This first value that you want is positioned in the first row and the first column. So to get it, we're going to multiply this first row by this first column. How you multiply them? First element in the row by the first element in the column, second element in the row by the second element in the column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 3 times 4, that's 12. And 2 times 3 is 6. Then this value here is positioned in the first row, second column. So to get it, to multiply this first row by this second column. Same thing again. First element times first element, second element times second element. First element times first element, second element times second element. 3 times 0 and 2 times negative 1. So the 3 times 0 is 0. And the 2 times negative 1 is negative 2. Then the third value out here is positioned in the first row and the third column. So to get it, to multiply this first row by this third column. Same thing. First element times first element, second element times second element. First element times first element, second element times second element. So it's, So it's 3 times 2 is 6. And 2 times 7 is 14. Let's move this bracket out some more. Then we come to the second row now. This value down here. What we want next? It's positioned in the second row and the first column. So to get it, to multiply this second row by this first column. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 4, which is 20, and 4 times 3 is 12. Then this value is positioned in the second row and the second column. So to get it, to multiply this second row by the second column. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 0, that's 0. 4 times negative 1 is negative 4. Then the last value out here, so we're talking now, is positioned in the second row and the third column. So to get it, to multiply this second row by this third column, I multiply the same way. First element in the row by the first element in the column, second element in the row by the second element in the column. First element times first element, second element times second element. 5 times 2 is 10. 4 times 7 is 28. So those are the values. And then now to get the final answer, we're going to add up everything, add up everybody, add up everybody. So this is going to be 18. 18 and 4 is 22, don't it? It's going to be negative 2. Negative 2 and negative 1 is negative 3. It's going to be much. 20 and 2. 20 and 2, right? So it's 22. It's going to be 22 and 7. 22 and 7 is 29. It's going to be negative 4 and 3. 39? What's supposed to be 12? Oh, it's supposed to be 12. Oh, my mistake. All right, let's go and correct that. It's supposed to be at 12, not 2. It's supposed to be at 12. 12. All right, so this is 39 then. All right, thanks for that. All right, where we reach now? We reach negative 4 and 3. Negative 4 and 3 is negative 1. And then this is how much now? This is 38 and negative 5. 38 minus 5 is 33, don't it? 33. That is the answer. 3 marks for that. Next question, find the inverse of A. Inverse of A. So A is 3254. A is 3254. A is 3254. Let's put on the screen so we can work from it, right? Now, A to the minus 1 is 1 over the determinant of the A times the adjoint of the A, which is 1 over the determinant. Determinant is the first diagonal product, which is 3 4 is 12, minus the second diagonal product, which is 5 2 is 10. That's the determinant, 12 minus 10. Multiplied by the adjoint. The adjoint is obtained by interchanging these two elements on the first diagonal. Switch them around. So the 4 goes here and the 3 goes there. Then the elements on the second diagonal, they leave them where they are and change the sign. So leave this where it is, change it to a negative 2. Leave this where it is, change it to a negative 5. And this under here is just a 2 now. This under here is just a 2. The determinant is just a 2 under here, so. So the final answer is obtained now by dividing. That's a to the minus 1. You divide each of these values now by this 2. So you're gonna get, let's put over here, sir. So we're gonna get 4 divided by 2 is 2. This 4 divided by 2 is 2. Minus 2 divided by 2 is negative 1. Negative 5 divided by 2 is negative 2.5. And 3 divided by 2 is 1.5. And that is your answer for inverse of E. Very good. Next part now says, write down the matrix, 2 by 2 matrix, represent A times A to the minus 1. Everybody must know that. A times A to the minus 1 is equal to the identity matrix, which is the matrix 1 0 0 1. 1 free mark that. End of this test. And that is that. Is that. All right, we shall do it tomorrow again, guys. 11 a.m. We'll do one paper tomorrow. And then Monday, remember, bring your questions Monday. Prepare your list of questions that you want to explain on Monday. That's what we're doing Monday afternoon. We'll just have a little talk. And we'll kill the exam on Tuesday. Kill it. It shall die a natural death on Monday. All right, on Tuesday. All right, guys, that's it. Very good? All right, do it.
Yes, sir.
All right, so tomorrow at 11 a.m., everybody. 11 a.m., we'll do another paper. We'll work it out again afterwards. All right, bye, everybody. Hold on.
Bye, sir.
Bye, sir.
Okay,
Well,
bye-bye.
sir, and happy belated Teacher's Day.
So again, oh, thank you very much. Thank you very much. All right, 11 a.m. tomorrow, we shall do it again, all right? Okay, bye. I'm end it now.